Hi, it's John Holloman. We're on our way back to NASA's Jet Propulsion Laboratory, where some folks without much movie star quality continue to make their way onto the list of people we know on a first-name basis. People like Matt Golombek, Pete Smith, Donna Shirley. Another household name is that of John Zarrella, a man who has taken this complicated story and made it simple enough even for me to understand. Old friend, I hear you've gotten a sneak preview of today's picture show. Is this going to be another one of those knock our socks off days?
Well, it may well be. The interesting feature will be the first fender bender on Mars. The Sojourner rover drove a little too close to Yogi. What happened was that the sniffer, the spectrometer, did not hit where it was supposed to. When the spectrometer didn't hit, the vehicle kept going to a predetermined place, and the front wheel actually rolled up onto Yogi. So the image will show Sojourner with its wheel rolled up on top of Yogi, and they're going to have to back off now and then reposition Sojourner and make another attempt. These things they've practiced in the past, but this is a situation that, you know, they'd hoped wouldn't happen, but it did, so we have the first fender bender on Mars. And John, 200,000 hits on the internet so far this week. Some tremendous interest still being generated by this Mars Pathfinder and Sojourner mission. John?
Yeah, let me ask you about a fender bender. When I have fender benders in my car, that means there's some damage to the car. Is there any thought that maybe there's some damage to the Sojourner rover?
No, does not appear to be. In the image, you can see that none of the body of the vehicle hit. It just rolled up that one wheel. So now we're going to go on inside and listen to the briefing. They're starting to talk now.
81 megabits of data, which again is more than we were obviously expecting to have, but we've been able to transmit for approximately 3 hours on the high gain yesterday. Among other things, things we did yesterday were things that were downlinked were more of the insurance pan that we acquired prior to deploying the IMP mast, the rover movie that Justin will speak about in a few minutes, a number of images acquired during the night of the atmosphere, the pictures of stars, and also sunrise and sunset images, and the standard meteorology information that we get every day. So that comprised the bulk of the lander activities. The rover activity yesterday, as was probably discussed yesterday, was we're still attempting to get the APXS on the rock we call Yogi. Yesterday, the rover was instructed to back around in sort of a circular path, and actually, why don't we put up the first image? You guys can see where we ended up. To back around from approximately down here, essentially backed around to the point where it was going to put the APXS right here on this near vertical face right here. And as you can see, it's a little bit hard to see in this image, but what happened was that the lander, or the rover, moved a little bit further than we expected and actually drove actually this is the left rear wheel. This is the front of the rover over here. The left rear wheel drove it up onto the face of this rock, which is actually not really unexpected. We've seen this sort of thing in tests before when we're trying to do this type of fine placement. And this is really showing you the true capabilities of the rover to essentially protect itself from things that we might inadvertently tell it to do here on the ground. What basically happened is within the bogey system here, it has a set of potentiometers which detect when the angle gets too high for an acceptable traverse, and it essentially stops wherever it is. And so in this case, it stopped with the wheel sitting there sort of partially up on the rock. What we'll do today, in fact, we've already built the sequences and are currently testing them, is essentially just to drive slightly forward, turn a little bit, and back the APXS up back into the rock. And we feel really confident, given how close we are, that we'll be able to put it on Yogi today. So this, while it may look a little interesting, this is definitely something that we've tested, and we're really truly testing out the capabilities of the rover at this point. So let's see, other things going on today. We have a little bit less downlink today planned, only about 2 hours. We're sharing the 70-meter antenna we have at Canberra with the Galileo project, and so we have to cut short our downlink by a little bit. Nevertheless, we'll still get about 53 megabits of data, split into actually 2 different downlink sessions, one that occurred about 6 p.m. this evening for about half an hour, and the other one which will be about an hour and a half or so, starting at 12:30 a.m. tonight and finishing at about 2. Again, that downlink will include sort of the normal set of products, the end-of-day image like this one, the spectral spots of different targets around the lander. But also we're going to reacquire a major panorama called the Gallery Pan, which is a full 360 color panorama from the lander all the way out to the horizon. So it'll be the first real true color of everything.
While we're watching this, we're going to give you one more chance to look at that first fender bender on Mars. You can see, if you look very closely out on the chin of Yogi Bear, you can see the forward wheel of the rover as it moved up on that side. We'll keep listening while you look at this picture.
APXS on the rock will take a set of images as well from both its forward cameras out of the area off to in front of the rover, plus use the rear camera to look at the spot at which it placed the APXS. So we probably won't get that data back tonight because of the priority of getting this full color pan, but we should get it tomorrow, and it should allow us to see very clearly where we put the APXS down. So with that, I'll pass it on to Justin. He can talk about the movie.
Okay, thanks, Richard. The image that Richard showed, the rover end-of-day image, was designed to assess the location of the rover and use the stereo capability of the M camera to help the rover team plan the traverse for the next day. One of the things that we've been experimenting with the past few days or during the mission is the idea of taking pictures of the rover as it moves around and assembling these pictures into a rover movie. These images are useful for the rover team, because they can see how well the rover actually follows its intended trajectory, and they're also just fun to watch. So without any further ado, why don't we go ahead and roll the movie here. This is the rover on its way to Yogi. It's moving, takes a turn, and if you look at the APXS right before it starts driving forward, you can see it pop out ready to jump on the rock. So this actually allowed the rover team to instantly assess what actually happened with the rover. It actually drove a little too far forward. It got a little too enthusiastic. And of course it has its own personality, and it can be shown here. So basically what we do to generate this movie is we plan with the rover team, and they of course know where the rover is going to be. So we get these points on the Martian surface and get the timing so that we can point to these points when we think that the rover will be there. And we've been pretty successful in predicting these points. We're getting better and better at it. You probably saw a couple days ago, the first rover movie, the rover just took off out of the scene because it went faster than we thought it would. But now we're getting an idea of how fast it goes, so we're getting pretty good at doing this. And that particular movie was a 20-image movie. The images are compressed at 24:1, which is still pretty good for the movie. And it played about 40 times real speed. The rover actually drives fairly slow. So to show the movie, we speed it up, and it makes a nice little assessment set of images. That's all I had to say about the rover movie. I just wanted to show one more slide. The rover team really wanted somebody to show us at the press conference today, so if you go to the screen, that's the image from the rover, one of the front cameras. You can see the lander on the left. That's all I had to say. I'll go ahead and pass it on to Carol.
Okay, our project is called Virtual Reality for Mars Pathfinder, and this is probably going to be the first that you guys have heard about it. We were selected as participating scientists, and I'm actually the lead representative, but what I represent is a team of people at NASA Ames Research Center in a group called the Intelligent Mechanisms Group that's led by Michael Sims, who's sitting over here. Raise your hand, Mike. The idea of this project was to provide scientific visualization with a high-fidelity sense of presence using photorealistic virtual reality. So what I'm going to show you is actually not a video. It's back on the in Building 230. Ted Blackman is running our real-time terrain model. And so how this works is we start with a grid and a lander model. And you can see the, I don't know quite how to run this mouse thing here, but here's our lander model down here in the center. And the first thing that we get is lander orientation. So from that, we orient our lander so that we're lined up with north angle on the spacecraft. And from the first set of stereo images, we start to develop, from the stereo disparity, we develop a terrain model. Now, how we're doing this is we send IMP data back to NASA Ames Research Center, where we have a team of people who are generating from each, basically the parallax on the stereo images, are generating a three-dimensional terrain model which has an XYZ position for every point on the terrain. And so each IMP image then is used to generate XYZ position, and then the pixel information, the color, the image information, is projected back on that three-dimensional terrain using a process we call the stereo pipeline that was invented by Eric Zabinden of our team. So we start with this blank grid, we pop the images into the grid, and then the information is fully there to do a fly-through of the model. So Ted will start zooming around in the model so you can see the capabilities. So back here, as you see, we have an image of, not really getting it with this pointer here. We have an image of the rover, and we can pop up the names of the rocks within the terrain model, and here's Yogi, and here's Barnacle Bill. And this is a real IMP image. And any place you don't see data is someplace that was actually shadowed when these images were taken. So the rover was in the way, basically. So you're not seeing a terrain model where the rover was in the way, even though you can zoom around and see the back side of things. As I say, all the data is being shipped to Ames, processed by our team at Ames, and then shipped back here. And the whole round-trip process is only taking us about 15 minutes per quadrant of the big monster panorama, or about 2 minutes per image pair. So one of the things that we can do with this, we can use it as planning and a scientific analysis tool, as I was mentioning. We can make measurements. So for example, Ted's going to illustrate making a measurement between Barnacle Bill and Yogi. So we provided this to the rover team and to the science team in planning. Okay, we're going to do this traverse from Barnacle Bill to Yogi. How far is it? And another thing that we can do is we can take directions, and maybe we'll spend a couple minutes taking directions from the audience, but I'm going to ask Ted to cruise forward and look under Yogi. One of the things we were able to do with this model is to see that there's actually a big overhang at the front face of Yogi, and that's why we couldn't drive the rover there, because it would literally have gotten under that overhang and possibly gotten stuck. Does the audience have any requests? Some place they'd like to cruise to?
Table Rock.
Table Rock, okay. Flat Top, I think that's what we're calling it.
Flat Top.
So, Ted, why don't you cruise over to Flat Top? Sometimes you have to go to another perspective so that you can move around. We have IMP viewpoint. We have a perspective that allows you to see a polar projection of the terrain. So there's Flat Top. Okay, so to not use more than my share of the time, we'll go back to the perspective of from the rover. We can incorporate into the model rover images. So going back to the perspective of from the rover, looking back at the lander, Ted's going to load that image in. You see that billboard popped up there? And zoom in, and here's the rover now looking back at the lander. So now with this capability, we can start filling in the back sides of rocks and really filling this model out with the rover images as well as the lander camera images. As you can imagine, we're having a lot of fun with this. And plus, it actually is a very useful tool for doing image planning and analysis. All right, I think we'll stop it there. No, actually we can't, because that data, you see those outliers hanging up in space, it's actually only good, the IMP camera disparity is not that great. The eyes aren't that far apart. So any information in stereo is only in the near field, so we're only good out to about 15 meters. And so things on the horizon, you know, the Twin Peaks are a kilometer or more away. You won't get enough information to render those in a stereo model.
We're going to take a quick break. We'll come back and see some more of these fabulous pictures and computer-generated things. What will they give us next? Stay with CNN. Our journey to the Red Planet continues. Bob Reed at the University of Arizona is explaining now to the news conference how the scientists figure out where they're going to go next to study. While he talks about that, we're going to look at the movie made of the rover over the past 24 hours as it made its way over to the rock we've come to know and love as Yogi Bear. We'll watch it a couple of times and listen to Bob Reed.
The soils jump out very nicely here in this representation. You can see that red drifty material is now very bright. It's very red, but this other soil unit is much darker. And this tells us quite a bit about what we've definitely got two different types of materials on the surface here. Something interesting here, this very bright area here, this is actually the shadow in the previous image of Yogi. Well, why is this so bright? Well, bright means red. Since it's in the shadow, the only light hitting the area in here, it comes from the sky. And since the sky is red, we see it show up here. So this is actually a measure of the sky brightness. Going over now, we see that these two rocks that were maybe a little more indistinct in the previous image show out significantly brighter here. They're much redder than the surrounding terrain. And finally, we get over here to Scooby-Doo. And this is very, very interesting. Now, you notice in the previous image I showed you, it was rather bright, but here it comes out as dark, which means in this representation that it's not as red as other objects in the scene. Well, this is very interesting, because what this means is this is something we haven't seen on Mars before. We've seen dark things, dark objects like rocks that are not very red, and we've seen bright areas that are very red, like these dust patches. But we've never seen something that's very bright, but also is not very red. So this is a very interesting object. We've never seen anything like this before on Mars. It's the whitest thing we see in the scene. And it's one of our primary targets for further study. And finally, just to show you how we keep learning things as we go in real time, this bright object right here, we discovered this as we were putting these panoramas together for the press conference. First, we thought it might have been a bad pixel or a misregistration, but it's a real object, and it's very red. It's one of the reddest objects we've seen. And if you go back and look on the original image, it's a very dark, deep red object. And this has become another one of our priorities for study. So the rover, we hope, will be heading over in this direction to give us some more information on these sites, and we'll be targeting it with the IMP to get a little more information over here. Just kind of a review. These are the things I've mentioned, and just gives you an idea of kind of what we're looking at. These are just some interesting objects based on color that we see in this particular scene. And again, I like to point out Scooby-Doo. It's the whitest object we've seen, and I think we'll probably be hearing a lot more about this in the next few days as we get some more information on it. Thanks.
I'd like to take you from the dense rocks of Mars to the tenuous atmosphere of Mars. And to do that, I would like to give you two progress reports from the ASI MET team. First of all, I'd like to put up my first figure, which is the weather forecast and weather report for Mars. And no surprise to you, it is basically the same as it has been for several days now. The atmospheric pressure at 2:55 p.m. local Mars time on Sol 6 is about 6.76 millibars. The high temperature is about +8 degrees Fahrenheit. The low temperature was approximately -100 degrees Fahrenheit. And there was a light wind from the west. The forecast for Sol 7 is pretty much the same thing, so that's no surprise. At this season and time, I imagine future astronauts on Mars would not have much to talk about as far as the weather goes. It would not be a very popular topic of conversation. The second part of my report is actually of a continuing story that we started to present last Monday to you, which is what is the atmospheric temperature profile in the Martian atmosphere. At the day after landing, or the day of landing, excuse me, both Tim Schofield and Rob Manning presented to you deceleration profiles of the deceleration history of the probe as it went through the atmosphere. On Monday, we derived from those deceleration profiles a density profile showing how the atmospheric density on Mars varied from approximately 130 kilometers altitude down to near the surface. What I'd like to present today is the temperatures that we've now derived from that atmospheric density profile. However, before doing that, I'd like to sort of refresh your memories as to a controversy that's existed in the Martian atmospheric sciences community. The question has been, has Martian climate changed significantly since the era of the Viking spacecraft missions in 1976? And as far as this investigation is concerned, the basic question is the atmospheric temperature in the interior of the Martian atmosphere cold today, or is it warm as it was at the time of the Viking spacecraft missions? And I would like to now show the profile that we found, which is the next figure. Thank you. I'd like to walk you through this profile, assuming I can get this cursor to work, starting at the very top, which is what is the part of the profile that Mars Pathfinder encountered first. Up here at about 120 kilometers down to about 60 kilometers, we find that the blue line, which represents the Pathfinder temperature profile, versus the red line, which is the Viking temperature profile, that the atmospheric temperatures are quite a bit colder than they were at the time of Viking. This is only for the upper atmosphere, however. What you might also notice is that there is this pronounced minimum here at approximately 80 kilometers, and that is the coldest temperature ever measured on Mars. It's a chilly minus 275 degrees Fahrenheit at approximately 80 kilometers altitude. As we now go further into the atmosphere, as Mars Pathfinder did, we reach below 60 kilometers altitude. We find that the temperature profile is actually very similar to the Viking atmosphere profile. In other words, from about 60 kilometers down to about 13 kilometers altitude, the atmospheric temperatures on average are indeed as they were approximately during the Viking era. I'd also like to point out that there are features throughout this profile that are undulations in that temperature profile, and those are very interesting to meteorologists because they presumably represent some form of atmospheric wave, possibly solar tides, as were discussed.
Well, they've done it again. Wow, this reporter. Great new pictures of Mars. The most significant picture of the day's briefing. The little rover that could, roving its way over to a rock known to us all as Yogi Bear. Here's what that movie looked like. The scientists on the ground are using a camera back on Pathfinder to take these shots. We'll show them to you again and again and again. John Zarrella, did you get a sneak preview at these shots, or were you watching them for the first time, same time I was? And what did you think?
I hadn't seen the movie. I saw the two still photos, this one and the one that looks like it's taken through a fisheye lens, which is the one that's taken off of the Sojourner rover. And I can tell you, we don't see it clearly in this video, John, but it actually runs over the rock named Boo Boo that we were telling you about, the small one right in the front of Yogi there that we can't really see too well in this picture. They've got several other names now: platypus, souffle, egg, chimp, hedgehog, and they have a little flat top as well. I went and checked the board today.
Yeah, still no
John?
Zarrella. We got a color photograph made from some of the computer imagery from Mars. I've got it here on the anchor desk, John. And what we've done is taken our little rover model and put it about where it is on the surface of Mars with its spectrometer, its sniffer, up against the back of the rock Yogi. This is the rock Yogi. The rock Boo Boo, which John was just talking about, is kind of caught in the glare, but it's right there. Very dark rock, according to the people who were explaining these pictures to us a couple minutes ago. We need to let you know what we're going to be doing for you over the next couple days. It'll be another briefing, 3 o'clock Eastern Time, roughly 22 hours and 3 minutes from right now. We'll be there for that live, as we always are. But tomorrow night, 10 o'clock Eastern Time, 7 o'clock Pacific Time, John Zarella and I will be here with a cast of dozens to replay for you every single picture we have seen from the surface of planet Mars in the past 8 days. It's going to be an hour-long special. This is the thing you ought to tape record for your children and your grandchildren, because it's going to be very good. And we're going to talk to the experts about what has happened so far, what is going to happen, and what it all means. Inside Politics coming up next. Thanks for being with us for this half hour. See you soon.
A fender bender. The latest pictures from the Red Planet show the Mars Pathfinder's rover ramming one of its wheels up onto a Martian rock scientists call Yogi. Project team members at NASA's Jet Propulsion Laboratory said Thursday it's all part of learning how to drive the roving mini-geologist.
It actually drove a little too far forward, got a little too enthusiastic.
The bogey system here, it has a set of potentiometers which detect when the angle gets too high for an acceptable traverse, and it essentially stops wherever it is.
The minor mishap means the rover will have to back off, reposition, then try again to planet's chemical analyzing alpha proton X-ray spectrometer on Yogi's side. Meantime, scientists have worked up new moving pictures of the rover using images played at about 40 times the real speed. Also, there are now virtual reality pictures of Mars, providing a way to better measure the size of certain rock formations. A three-dimensional terrain model set up from stereo images shows that the bear-shaped rock called Yogi has a huge overhang, which could have posed a real problem for the Sojourner.
And that's why we couldn't drive the rover there, because it would literally have gotten under that overhang and possibly gotten stuck.
Only a portion of the 360-degree color panoramic photograph scientists call the gallery pen is ready for show. Scientists also say new data suggests that each and every particle on Mars is more or less magnetic. Already, the Pathfinder science team thinks it has answered the burning question: has the climate of the Mars atmosphere changed since 1976 and the Viking spacecraft's entry?
The atmospheric temperatures are quite a bit colder than they were at the time of Viking. This is only for the upper atmosphere.
After its Independence Day landing, scientists at JPL hoped Sojourner could collect data for at least 7 Martian days. The way things appear now, they say they hope to extend the process for perhaps weeks. Jennifer Author, CNN, Pasadena, California.
For the past 8 days, we have been showing you remarkable pictures from someplace far away, the surface of the planet Mars. The folks at the Jet Propulsion Lab in Pasadena, California, now say they're going to have the biggest picture show we've ever seen of pictures from Mars, some of which we've not seen before. CNN's John Zarella joins me from the Jet Propulsion Lab. John, I don't know what they can do to make this much better as far as the picture content. Maybe there'll be a lot more science news about how Mars is different from planet Earth, or I don't know. What do you think?
Well, I can tell you that there is a level of excitement I haven't seen here since the day of the landing. The imaging team is just ecstatic. And what I can tell you is it's going to be 360-degree panorama of Mars with the 3D red and blue glasses that if you got them there, wear them, because it's going to be something. And that should come from the second presenter in the group is going to unveil this remarkable image. I just talked to Peter Smith, and you'll literally be able to see as if you're standing on the surface of Mars. That's what it's going to be looking like if you got the 3D glasses. John?
All right, John Zarella, they're continuing to introduce the panel there at the Jet Propulsion Lab. Looks like this briefing's about to get underway. Let's go.
What's been going on in the last 24 hours with the spacecraft? We certainly had sort of an interesting day yesterday. I explained some of this already this morning, but yesterday we had a full slate of activities planned to uplink to the spacecraft. Unfortunately, we had a little problem, a timing issue between ourselves and the DSN, the Deep Space Network, where we attempted to command the spacecraft, or to send a set of commands to the spacecraft at a time at which the spacecraft receiver was off. Generally, what happens at night on the lander is we turn the receiver off in order to conserve power, and then we turn it on in the morning right before the point at which we would get commands, we would want to send commands. Because of a timing overlap issue, we turned the spacecraft receiver on about 10 minutes after the point at which the DSN attempted to signal us or to turn the transmitter on and to lock up the receiver. So as a result, we were unable to get up the set of things which we were attempting to do yesterday. We did get a signal from the spacecraft indicating that it was fine, it was healthy, there was no real concern, but we just didn't get as much accomplished as we'd liked. And as the team joked later at the conclusion of the day, on the 7th day we decided to rest. So that's, and actually I think they all appreciated it, even though it wasn't intentional. Everybody got a lot of sleep, and I know that they valued that. So basically what we're going to do today is to essentially just do what we were going to try yesterday. At about 3 o'clock this afternoon, we'll begin commanding the spacecraft again. This time we've already made sure that we have the receiver on the spacecraft, and we'll be ready to send commands to it. And then what we're going to do is have it go through the same set of activities where we command the rover. As you'll recall, yesterday we were going to drive off the rock that it's on right now called Yogi and back up and put the APXS on it. And we're also going to acquire what we call the gallery pan, which is a full 360 color image from this spacecraft all the way up to the horizon. And we expect to get that down this afternoon, or this evening actually, between the about 11 o'clock to midnight time frame, which is when the downlink session actually will occur today. With that, I think I'll let Larry tell you about what the science team has been up to in their time off. So.
Time off. Right. We don't have time off. I'd like to share with you what I see as a fundamental change in the way we think about Mars, and how it will have, I believe, a dramatic effect in how we plan the rest of Mars exploration. As the geologists have come up over the last few days, you've gathered that Mars is a complex geologic planet. There's been a diversity. A geologic textbook, the glossary of terms in terrestrial geomorphology are found throughout Martian geology. Virtually everything you could imagine is there. But today, modern Mars is a dry, cold, windy desert. And so the sands of Mars shift back and forth, and in some cases mantle, in many cases mantle, bury, and make this, the geologic history of Mars hard to really see. And the first still that we have, you can see this is from the Viking 1 landing site, and what we see here is a variety of mantles of sand dunes and other kinds of alien deposits which have been slightly cemented and so forth. But they mask, to a very large degree, the subsurface geology. The real record we're after, and particularly if we're looking for clues to ancient Mars, and when we send spacecraft to land and bring back samples, this kind of a landing site would be difficult. But the Mars Pathfinder site, serendipitously, happens to be, the next still you can see, a zone in which the dunes are very sparse. Here are two of the small dunes that are in the near field of view. But for the most part, what you see is a surface which is being stripped down. In other words, the mantles that are prevalent at the two Viking landing sites are almost gone here. There's a few residual dunes, but for the most part, we see boulders standing on the surface if they're perched above the soil. And the reason is because the soil is being scoured in a very delicate way down into the surface, exposing the skeletons of this complex geologic history. And so the scouring process has exposed this complex array of soils. There may be evaporites, there may be a whole range of things that are associated with these ancient catastrophic floods. So as if we're at an archaeological dig and the wind is our crew. So this delicate exposure is what we're looking for. What are the ramifications for future Mars exploration? The next still shows where we are and perhaps why we're seeing this kind of phenomenon. The Viking 1 landing site that I showed you is off over in this direction, actually slightly off the slide. And that's this thickly mantled area. You see here sort of three parts of Martian geology. There's old highlands, ancient craters, kind of an intermediate brownish zone, and then this dark zone. You start to see some contrast in details. What this is a curtain. The Martian sands of time are being drawn back, and the Pathfinder landing is right on the edge of the curtain. And we're seeing down into this very, very subtle geology. It means three things. Number one, we need to go to places in which the erosive energy is greater than the depositional energy, so that things are exposed. So we can find the sedimentary rocks, so we can find the interesting samples that may bring back the clues of life. It also means that we're going to land in some places that are rougher than a cob, and that we need to start gearing the exploration program in that direction. The technology of the sort we use on Pathfinder is one way to get into these extremely rough environments. But this may, in the end, turn out to be a smooth case for what we're really after. And lastly, it's unlikely that we're going to take rovers and drive them around thousands or hundreds or even tens of kilometers through this kind of complex, rough terrain. So you'll see, I think, as we start to analyze this data, this whole pattern start to shift as we now are gaining some scientific and engineering comfort and confidence in how we go about exploring the surface of Mars and bringing back the right collection of materials. And that's what Pathfinder is really doing. It's giving us that set of knowledge where we're feeling at home geologically and as far as engineering on the surface of Mars. Looking at this position of the landing site, we have for you a couple of animations. The first one is what you might have seen if you'd been on the lander on the way in a week ago. So if we'll go to that clip, please. So here we're descending through the atmosphere. Parachute pops. And just toward the end, fire the rockets, the airbags, and down we come. We open our eyes, take a look around. Here's the rover getting ready for its, in the situation with the airbags, you can see kind of rolled up along the edge of the rover pedal there, kind of flopped over the edge of the ramp. Engineers solve that problem. Off comes the rover. And then this is a controlled color animation using images that have been seamlessly put together, the cartography done more completely. This is a more refined version of some of the things that Carol Stoker showed you yesterday. So our efforts continue, and I assure you that the video you'll see and the products will continue to increase in their clarity and their virtual reality, taking you to the surface of Mars over the weeks ahead. And finally, we've handed out some red and blue glasses for those of you in the audience, and those of you at home, if you have the right kind of cereal box in the closet, you get those out. Of course, if you're professional and you come from the USGS, you get better glasses. Of course, this is what any one would wear. And here comes the image processing lab with what's called an anaglyph. An anaglyph is a fancy word for what was done with 3D comic books 65 years ago. And it's basically a red-blue composite. And you can see in this anaglyph a lot of the erosive detail, particularly off to the right. If you look, you can see in 3 dimensions those rocks and cobbles being stranded above the stripped surface in the Martian Pathfinder Ares Vallis landing site. What a weird bunch, I'll tell you.
Cheers for Mendel.
As usual, the JPL Multi... petroglyph mosaic will be put up in the back, and after the press conference, we'll spend some time taking you on a geologic field trip onto the surface of Mars. With that, I'll turn the microphone over to Dr. Sabahi.
Actually, and I'm going to pass it on right to Dave because we decided to go 1, 2, and 3.
Oh, okay.
Well, what really happened on the 4th of July? There were no cameras, no set of eyes that we know of, at least, on the surface of Mars to witness the events that occurred in the night sky. Our only insight into what happened is the flight data recorded by our instruments on the way in, stored on our flight computer, and beamed back to Earth on the first 2 sols after landing. So while the scientists are busy consuming the science data, the engineers are excitedly diving into this vast set of engineering data, trying to figure out if the years spent developing models and coming up with designs actually worked exactly as planned. The entry, descent, and landing reconstruction process will likely take months, maybe up to a year to complete. And in the coming years, if you all have a favorite aerospace engineering journal, you'll very likely see some articles on Pathfinder in there. But what we're going to do today is give you a quick look at what we've discovered in the 1 week since landing. Let's see, our entry, descent, and landing reconstruction team is made up of engineers and scientists from across the country. Here at JPL, NASA Langley Research Center in Virginia, NASA Ames Research Center, and Lockheed Martin in Denver. We're going to try to determine our flight path, our aerodynamic heating, how our heat shield performed, parachutes, rad rockets, all the way down through landing. First slide, please. Okay, this is a slide that's been put together by the NASA Langley engineers. They were responsible for coming up with our aerodynamic profile. And the top plot here shows angle of attack on the y-axis plotted versus time from entry. Now, we have an aerodynamically stable vehicle, so we expected these angles of attack to remain near 0 throughout entry. But the Langley engineers did come up with several areas of instability where these angles of attack might kick up.
We'll take a quick break, come right back with more of the Mars Pathfinder Picture Show. Stay with CNN. And what they are reporting right now at the Jet Propulsion Lab is that Pathfinder performed remarkably close to the way they predicted it would perform. And other engineers speaking now. Let's go and listen in.
Computed by the navigation team before entry interface, and the ellipse around that marker you see is a dispersion ellipse that bounds the uncertainty in the prediction. Now up here with the yellow X, you see the landing site that's been established relative to the topography by the science team from imaging. They are different. Now the reconstruction that we've just finished up this morning from accelerometer and radar data says we were essentially right on top of the navigation predict. So it looks like in inertial space, that is the spatial coordinate frame that the navigation team works in, that they were right on the money within a kilometer or so of the targeted site, which is extraordinary. So this lends further suspicion to the theory that the discrepancy between these two sites is a result of imperfect knowledge of the topography in the navigation frame. So there will be something for the scientists to chew on there. We've also learned some things about what happened on board the spacecraft as it went in. As near as we can tell, the terminal velocity reached by the lander on the parachute was about 60 meters per second. There's an algorithm that ran in the flight computer on board whose job it is to control the retro burn that said we were coming in at 61.5 meters per second. That's about 140 miles per hour at the time the rockets fired. So it looks like the firing algorithm did a pretty good job according to what we've been able to learn so far. One of the other big questions we had was, did we pick up some horizontal velocity from the wind as we were coming down? We think we did, on the order of 20 to 25 miles per hour, or about 13 meters per second. At the time the retro rockets were ignited, we think we were about 98 meters above the ground versus the 90 meters that the firing algorithm was shooting for. That error is well within the tolerances of the firing algorithm, so it looks like it did a good job. And at the time the lander was cut from the bridle, we think we were about 21 meters or 65 feet above the ground, and that the The lander had just started up again. We think we had a slight overburn and that there was a residual vertical speed of about 1.5 meters per second after the bridle cut. So we took just under 4 seconds to fall to the ground. We think the airbags and lander hit the ground at about 18 meters per second or 40 miles per hour, of which about 12.5 meters per second was horizontal. This is well within the design range of the airbag. It looks like, I think as Rob Manning indicated a week ago, our initial guesstimate of...
Well, they expected it would hit the ground at 55 miles an hour. They managed to slow it down to 40 miles an hour before it hit. Maybe one of the reasons the rover and the Pathfinder working as well as they are. We'll take another quick break. I'll listen in while you're watching something else, and I'll tell you what happened when we come back. Stay with CNN. Welcome back. John Holloman at CNN Center. We're going to play back for you a 3D image of the Martian landing zone. The NASA engineers at Jet Propulsion Lab rolled it out in this briefing that we're watching right now just a few minutes ago. And if you put on 3D glasses, if you happen to have a set around the house, you'll be able to see a stupendous amount of relief in this picture. I'm going to put on my glasses. The bigger the size of your TV screen, the better it's going to look to you. Yeah, you can see some relief in the picture, particularly up close where the lander and the rover are located, and even out there at the Yogi Rock and some of the other rocks as it pans by. The folks at the Jet Propulsion Lab tell CNN that they're going to mount this on some easels for us so we can go through the whole thing and get a very good, slow recording of it, which we will play back at 10 o'clock Eastern Time tonight on our 1-hour special, Journey to the Red Planet, the little rover that could. So we want you to be back here with us for that. You want to see this very much up close and personal. Now, the briefing continues with engineers. This is Dara Sabahi, the mission engineer, talking about how well the probe was designed and how well it operated as it made it down to the Martian surface during the first few minutes of its time on Mars.
2 airbag, full system airbag deployments, and we had at least 8 gas generator firings. We had, I think we lost count at what point, more than 150 airbag retraction and petal deployment tests. And to give you a sense, all of them were occurring in parallel. They're all occurring with the hardware being built. They're also, everything is occurring with the end-to-end simulations being performed. So we were sort of on a roller coaster, running with it. And one thing I can say is that the roller coaster had a lot of painful downs and joyful ups. And it wasn't easy to get here. And I personally am very grateful to all the people that were committed to make this system work. Thank you. I'm done.
Okay, for those of you that don't know me, I'm Tony Spear, the project manager, and I'm going to talk about the mission objectives accomplished to date. However, before I do that, this is my sayonara press conference. When a function on the cruise stage was no longer needed, like propulsion, for instance, you know, when we did the last maneuver, I would say, and the team would join in, sayonara, Morgan Parker, we don't need you anymore. And when we didn't need the star tracker or the sun sensors anymore, we would say to Miguel, sayonara, Miguel, who is, by the way, the king of Argentina. He's been knighted. I'm going on to my next job next week, which is bigger and better, so stay tuned. I'm going to spend a few minutes reminiscing. The most frequent feedback, the most frequent comment that I and the team got after launch was, Tony, we really never thought that you were going to launch under the cost cap, okay? Then the most frequent feedback after landing was, Tony, we really didn't think you were going to land safely. And throughout the 3 years, my young team, you notice...
Tony Spear, the only really gray head in that whole room of Mars Pathfinder scientists, bidding a swan song to his team. He says he's off to bigger and better things. We'll see if he can do bigger and better than this. But he was the manager for this project, the person who put it all together, got it off the ground, and now that it has completed its primary science function, the first 7 days on Mars, he's moving away. The rest of his team are going to be there. And so will we, to watch the additional pictures as they come in over the next few days. Talkback Live is next. I'm going to get up from this chair, run down 4 flights of stairs, and be with Susan Rook and the gang down there. And we'll talk about Mars if you like. You know how to talk back live. Also, for our international viewers, thank you for being with us for this latest in a series of dramatic picture shows from Mars. There'll be more of them. Stay with CNN.
A little miscalculation means a little bit of trouble for the Earth-made rover on Mars, but the U.S. Space Agency remains optimistic. In fact, earlier Friday, it was looking at the situation through rose-colored glasses. CNN's John Zarella is at the Jet Propulsion Laboratory in Pasadena, California. John?
Good evening, Judy. And here are those rose-colored glasses that we all had the privilege of looking through earlier today. The Jet Propulsion Laboratory today, a major day to display a piece of three-dimensional art, really, of the surface of Mars. 360 degrees. You can see it there, and you can see those colors. Now, if anybody at home has 3D glasses, run and put them on real quick, and you'll get sort of an idea of what it looks like. It's not great on television, but up close and personal, as we got to see it here, you can see the rolling hills and the undulations and what appear to even be fractures in the rocks. A tremendous tool that is not only a wonderful sight to see, but actually helps the people here, the rover drivers, the rover coordinators, to see really the kind of terrain that they are dealing with and the kind of terrain that the vehicle would have to traverse in order to move out very far from where it is now. It's certainly going to be a challenge as they continue to move away further from the landscape. Now, the news of the day beyond these wonderful pictures, this 360-degree photo, and you can see there, that's one of the ramps. That's the one that never got to the ground. That ramp is actually sitting suspended in space. It never fell all the way down. The rover came off of the other ramp, which the image is panning to now. And that's when the folks here at the Jet Propulsion Laboratory got to see it. That's Peter Smith, one of the imagers here, putting on their glasses and had the opportunity to actually see that photo. It's now, there's the actual photo itself. It's now on a back wall. But what the news of the day was, yesterday they had planned to send commands to the vehicle that would allow it to back off of the Rock Yogi. Well, the commands didn't get there. A timing and communication error. There's some video there, and I want to bring in Art Thompson. And Art, you can tell us about, you are the rover coordinator, what happened and what you're going to do next.
Okay, well, as you can see in this, this rover movie, we actually found Yogi, but we found it with our left rear wheel. We're off by about 10 degrees, and just so happens that Yogi sticks out a little bit further than we had anticipated, and we got our wheel caught on it. That's nothing we haven't experienced many times in tests here on Earth and in our sandbox. And in fact, we went in as soon as we got this movie down in the sandbox, set up this configuration, and we tested sequences to actually drive off the rock and replace the APXS on Yogi where the wheel is now.
Now, Glenn Reeves, you're here to join us too. You're going to be the catcher.
That's my job.
For 7 months, they have been promising me, since before the launch, out at the Kennedy Space Center, that I could finally drive your rover. Now, I'm going to drive it. I have a history of running into things, but with automobiles, so I don't think I want to do it too much. But we're going to drive the rover.
Take care of our baby.
Now, this is forward, right?
That's
okay,
right.
We're going to move forward. We're going up to the rock. Will it go over this rock?
It should.
It should. It's actually going over the rock. Wow. Now I can turn it a little bit. We can, well, I should probably go the other way, shouldn't I, if I don't want to?
Well, you can go any way you'd like and then back it up.
Look at that. Oh, there we go. It's fabulous how this vehicle actually works. I better let you guys take over before I
Give it
run
to
it
Glenn.
off.
We'll let Glenn drive it off the table.
You can drive it. I don't think I'd be real successful as a rover driver. I don't have my license yet. Maybe I will. But anyway, now what they are doing is sending commands to the vehicle today, and they hope that what they will be able to do is now command it to step back from Yogi, reposition itself, and then they will be able to put the spectrometer up against it to start the analysis of Yogi Rock. We may have some data as to whether that was successful, whether they got those commands later this evening, and results and images probably released sometime early next week. So again, A wonderful day for the 360-degree images, and a day yesterday, as they put it here, on the 7th day we rested. The science team, the engineering team really needed a break. They were beginning to wear a little bit thin, so in essence, not sending those commands probably made it a very, very good day for all of them. This is John Zarrella reporting live from the Jet Propulsion Laboratory in Pasadena. Judy.
John, just a quick question. So they think the commands that they're sending today, tonight, will be received and the rover will be fine by Saturday?
Yes, exactly. As a matter of fact, they believe the rover will be fine tonight, that the thing was just a timing error. The rover really wasn't awake when the commands were sent, actually the lander, and by the time the command got there, the lander wasn't ready to receive it. So that's all it was, just a timing error.
All right, John Zarrella, thanks.
Exactly 1 week ago, the Red Planet got a visitor. And back on Earth, everyone's horizons began expanding. Whether you've been glued to the news from Mars or have only caught a glimpse here and there, this next hour is for you. It's about people, a most amazing place, and a little rover that could. Welcome to both our domestic and international viewers. I'm John Holloman at the CNN Center in Atlanta. This has been some kind of week. Since this time last Friday, we've seen more pictures and more views of Mars than ever before. And there's more to come. But this story isn't just about pictures. Tonight, we're going to tell you how a box of gears and gadgets the size of your microwave oven has captured the attention of a nation and a world. We're also going to tell you about a group of people who went to work last week with butterflies in their stomachs and lumps in their throats.
We have the
It was a good day at the office for the scientists, engineers, and thinkers at NASA's Jet Propulsion Laboratory when they got the word, or the code as it were, that Pathfinder had safely reached its destination, the Earth's most interesting planetary neighbor.
This is really exciting. This is the data we've been waiting for. This is the Mom, I made it, the safe arrival phone call. And this is what we've been hoping for.
Landing on Mars is like a lot of the harder things in life. You can talk about it and plan for it and rehearse it, but until it's done, it's like waiting for a baby to be born. This was Mission Control's version of a smiling obstetrician announcing, "You have a healthy baby, 10 fingers, 10 toes."
I don't think any of us expected today to go like it has. Every time we looked for the spacecraft, it was there. It gave us clear indications it was on the surface, that it was healthy within 3 minutes after landing. And now, just now, we received our first telemetry from the spacecraft. We're getting down the health of the spacecraft, and it sounds like everything is absolutely perfect.
How did Pathfinder do it?
3, main engine start. 1, 0, and liftoff of the Delta rocket with Mars Pathfinder. And the vehicle has cleared the tower.
After launching December 4th, the small spacecraft logged more than 300 million miles as it zipped through the solar system. That's more than 25,000 miles an hour. Getting it safely onto Mars's surface was a delicate operation. Here's how that worked. A few seconds before landing, enormous airbags deployed to cushion the landing on the cold and rugged Martian surface. Mission Control would later learn that this airy package would bounce at least a dozen times before safely settling. And for that to have happened, a lot already had to go right. If the parachutes, balloons, and heat shields had failed, that would have been the end of Pathfinder. The speed and impact would have destroyed it. There were plenty of other ifs. This is the first time a craft has landed on another planet without the use of thruster rockets like those used to safely get astronauts down to the surface of the moon.
The little engine that did. And we are just absolutely boggled by the fact that this fairly complex design that we've been thinking about and stewing over and testing and trying to make work really did the job.
First, there were the black and white images, and not long after, color. And now you know why even ancient astronomers called it the Red Planet. The simple answer? The surface of Mars is basically rusting. With each new image, new levels of excitement and a sense of wonder.
You might ask if there were living organisms once here. You might ask many questions about these pictures, and these are questions we too will be asking. But remember, the imagination is very important to understanding this mission, and we will try and help stimulate your imaginations as we will stimulate our own.
Pathfinder's petals opened to reveal the rover, about the size of a small microwave oven. Program manager Donna Shirley was adamant about the rover's gender.
Most of the rover team is men, and they grumbled a bit. And I said, hey, it's my rover. It's the only time I really got tough with them. I said, this is a female rover.
A Connecticut girl won an essay contest to name the craft. She called it Sojourner Truth, after the abolitionist of that name who spread the truth about slavery.
So this girl, who's 12 years old, wrote this really nice little essay about how Sojourner Truth would travel around Mars, bringing back the truth about Mars.
If you sense a lot of passion and personal involvement in this project, you're right on target.
It's really, really wonderful, and we're just totally in love with our baby.
And they have confidence in their baby. That's why nobody panicked when Pathfinder ran into its first problem when engineers looked at the first black and white pictures beamed back to Earth.
Okay, this image shows the airbag on the rear side. You can see how it's billowed up. That airbag is not fully retracted. We don't quite know why that is, but what we're planning to do, what the flight team is doing right now, is testing a sequence, and may have already even uplinked the sequence that will cause us to, and let me show you with this little model here. Okay, here's the pedal where the rover is on, and what we're going to do is we're going to lift that pedal up about 45 degrees, and then we're going to turn on the actuator that pulls the airbag, that's retracted the airbags, and we're going to turn that on for about 10 minutes and try to pull that airbag in a little bit more.
Flight rover, we have rover data. Yeah!
That set of new commands worked. It was now safe for Sojourner to make those first shaky moves.
The images that you've seen today show a completely deployed rover that has driven down a perfectly deployed ramp and gotten to the surface of Mars, making its first tracks in the soil of this new planet.
Rover, don't forget to call home occasionally.
The first rock to get its picture taken and to get sniffed by an X-ray spectrometer, Barnacle Bill.
It's called that because in the close-up view, it looks like it's covered with little lumpy barnacle-like features.
Pathfinder's two eye-like cameras sent back the ingredients for a panoramic view of the landing site. And a quick look at the rocks told geologists they might have been pummeled by enormous floods billions and billions of years ago. There's evidence of a 1,000-foot deep flood, one that moved rocks thousands of miles. It's those indications of water, and plenty of it, that have scientists thinking the planet may have supported life in some form. Look at this map and get a load of these names on the Carl Sagan Memorial landing site. There, the Twin Peaks, the Big Crater, the Far Knob, and the really far knob.
Rover has nestled up and kissed affectionately Barnacle Bill.
Sojourner continued to make her handlers proud. The rover stirred up some soil with its wheels so geologists could get a good look at some dirt below the Martian surface. Then it was off to shoot a bear. Just photographs, of course.
We'll turn the rover and drive towards Yogi, and at the end of the day, we'll take a full stereo from the rover eye, nice up and close. That's the way geologists want to look at it, nice up and close, and see what we can see in that morphology.
With moves like the crab, Sojourner is showing off some real self-sufficiency, getting around the craggy surface. And the research team shows no signs of wearing out either.
This is unbelievable. You have 70 scientists like kids in candy shops here at the end of fire hoses of data who just grinning from ear to ear.
One of the most widely traveled astronauts, Story Musgrave, says there's something almost hypnotic about our new relationship with our solar system neighbor.
The call is there. It beckons. The beauty of the place, it really does call. And with a brand new technology, with a very efficient small satellite that it came just scooting and screaming out in there, and it's there, it lets you know how doable the whole thing is.
Doable it is. The pictures, the enhanced pictures, just keep on coming. The first virtual reality look at Mars was shown Thursday, And it's not just a way to look at cool stuff. The scientists use it to better measure and estimate the size of rock formations. Which brings us back to these pictures of Sojourner. It shows the vehicle ramming a wheel up on the rock called Yogi. And because of a miscalculation, NASA missed getting its radio instructions to the rover, so that's where Sojourner remains right now, jammed against that rock.
We did get a signal from the spacecraft indicating that it was fine, it was healthy, there was no real concern, but we just didn't get as much accomplished as we'd liked. And as the team joked later at the conclusion of the day, on the 7th day we decided to rest.
Throughout the mission, from the very first pictures, NASA has been building what it calls the Monster Pan.
Take a look around.
A 360-degree look at the Martian terrain. And today, NASA came back with its latest effort.
And then this is a controlled color animation using images that have been seamlessly put together, the cartography done more completely. This is a more refined version of some of the things that Carol Stoker showed you yesterday.
This is just so good. The scientists at JPL had something else to show us today, something we're planning to show you. This is part of an old-fashioned 3D picture of Mars they put together. To see it in 3D, you're going to need glasses like these, so if you got some, dig them out now. Coming up at the bottom of the hour, we'll show you the whole picture. So if you have some of these old-timey glasses around, go grab them. Now, just ahead, a look at that group of scintillating scientists from JPL. Who are these folks? You know something? It was cool to be a scientist or an engineer this week. And it was hard for the rest of us not to smile watching the men and women at Pasadena's Jet Propulsion Laboratory so obviously enjoying doing what they do. Let's get to know them a little better. Here is CNN's Ann McDermott.
Yeah.
He rests. He rallies. He rocks. Meet Rob Manning, self-described nerd.
By the standards of our society, anybody who's fascinated by technical things is often considered a nerd. And, you know, I don't really mind that title because I wish more people were nerds, quite frankly.
Manning, the flight system's chief engineer, is the guy in the headset, the guy who's enchanted millions with his enthusiasm for space exploration, his enthusiasm for any exploration.
The time is here. Let's go. Let's find out about the world. Let's find out about our oceans. Let's find out more. Everyone can be a scientist in their own way.
It's been quite a year for Manning. His wife's expecting a baby, and then there's Mars. His only regret, he hasn't gotten around to trying to name one of those Mars rocks after his dog. After his dog.
They wouldn't let me name it after my wife.
Then there's Donna Shirley. Woo-hoo! Now, normally she's much more sedate, but the Mars Exploration Program Manager is excited about Mars, and she in turn excites audiences about it because she explains things clearly, simply, a skill she comes by honestly.
When my daughter was in preschool, I went over and taught science to the 3- and 4-year-olds.
3- and 4-year-olds?
We had them sliding down the slide, yelling, "Gravity!"
Gravity.
Blech.
That's Matt Golombek, the entertaining guy at all those news conferences.
You know, the sky's the limit here.
The project scientist says space was not a particularly big deal to him as a child. He got into rocks.
I'm a geologist by training, and I got into geology because I wanted to know how mountains got to be mountains and valleys got to be valleys.
Fortunately, he's got mountains and valleys on Mars. Now, if only he could get some rest.
My kids wanted to know why. They asked my wife, "Why is Daddy always on TV and not home with us?"
And what does Daddy say?
Daddy said, I'll be home real soon.
Soon.
Getting any fan mail? None.
Well, maybe he just hasn't checked. Donna Shirley's been getting some. So has Rob Manning. But don't worry, nobody's going Hollywood here.
I didn't do this job to be famous. I did this job to explore Mars.
Mars. Ann McDermott, CNN, Pasadena, California.
These are pretty remarkable folks. My colleague John Zarella, another remarkable person, is at the Jet Propulsion Laboratory with some of the men and women who've made this Pathfinder mission such a success. John?
John, I've got to tell you that we watched that entire first segment. It was great with our 3D glasses on here at the Jet Propulsion Laboratory. And there we are, all of us with our 3Ds. It was better in 3D, that first segment. Just fabulous. It's a fun bunch. You know that by now. I want you to meet everybody here in person now. Of course, the world has come to know all of these people. To my right, Donna Shirley, the head of Mars Exploration Program here at the Jet Propulsion Laboratory. And, of course, Matthew Golombek, soon to be on GQ, I understand. Matthew Golombek, who is the head of the science team here on this mission, on the Pathfinder mission. And, of course, Brian Muirhead. Brian, deputy project manager, but has been named project manager, and he is here with us as well. And Brian Cooper, who is one of the rover drivers. You didn't drive into the rock, did you?
That wasn't me.
It wasn't you that drove into the rock.
Poor Jack.
Yeah. I have to ask you, right out of the box, everybody wants to know, what do you do for an encore? Donna?
Well, we've got MGS coming up. Mars Global Surveyor is getting to Mars in September 11th, 62 days from now, goes into orbit, uses aerobraking to get into the right orbit. That means it skims through the upper atmosphere of Mars on every rev, and it's going to be a real circus to watch him do that.
Don't you sit and think, here you are, everybody very young, all of you very young.
Some
yeah.
of us very young.
What do you do for an encore, though? It's got to be something that's crossed a lot of your minds, right?
Well, John, after I get done with this wonderful experience with Pathfinder, there's another mission to land on the surface of a comet that I'm going to be responsible for, and I think that could be an exciting encore.
Wonders never cease, do they? How'd you get your rover driver's license?
Well, that's a good story, John. There was a teacher named Fran O'Rourke up in the state of Washington who had me come up and give a demonstration to their school, but what she didn't tell me is she also had the governor of Washington and the entire school there and media, and they gave me a driving test, and they gave me a driver's license on the spot, and then later Vice President Gore signed it. So.
You know, I have often heard many, many times that this was a rogue team. That you people were sort of, yeah, sure, let him go do this. We'll see if it works, kind of thing. How do you take that? I mean, it worked.
It worked. We did.
Now, that was part of our charter, John. We really had to invent the process of building spacecraft, and that's what it was going to take to do this job within the time and the money that we had. So we didn't mind being left alone, actually, to go off and do this job.
Well, and not just spacecraft, but the whole mission, the way the navigation was done with a very tiny navigation team. The rover, nobody had ever built a 10-kilogram spacecraft before. And the whole program's like that. You know, the whole program is chartered to pave the way for NASA to show how to do this stuff. And this team showed how to do it.
Matt, did you ever think in your wildest dreams that the kind of science that's coming back, this was an engineering mission primarily, but here you are with all of this tremendous science that you're getting?
Yeah, well, that was always my dream, actually. I mean, that was my job, in fact, was to dream about the science that we could get back and what we could do. And, in fact, how to change this thing. You don't want to send a red brick to Mars. That's, that's dumb. Let's do something where you can learn something new and really start investigating this planet. And so that's been my job since day one, is how do you take this entry, descent, and landing demonstration and make it into a really neat science mission?
And you know, the place we landed, I think, should be called Matt's place, because he's the one that picked it and sold it and got it to happen.
Right, we had talked about that on occasion. And really, from the point of view of a rover driver, Brian Cooper, you guys and the old saying, it's better to be lucky than good. I mean, you were both where you landed, because all around there, if we look at the 3D or any of the images, it would be a pretty rough ride even for Sojourner.
I think it's a perfect combination of rocks that the scientists are finding very interesting right near us, and yet they're spaced out enough that we can go around them, and that the sizes are such that we're not going to be in too much hazards driving around.
That was a real concern in the selection. They were worried if it was too much like Viking 2, where you had a lot of large rocks sort of equally spaced, it might be difficult to drive. And it just perfect. Perfect, perfect, perfect. I just can't help it.
It's obviously very easy to see how come they're very happy all the time. And now we've seen scientists giddy as school kids. How about school kids acting like scientists?
Hi, I'm Samantha Cravey. I'm 14 years old from Conyers, Georgia, and I was wondering if the red soil on Mars has any similarity to the red Arabian deserts.
We are at the Jet Propulsion Laboratory in Pasadena, California, not on Mars, as it looks like. The question going to that commercial break, Matt Golombek, why is Mars red?
Well, we think it's a rust pit, effectively. It's dominated by hematitic minerals, which if you take your bicycle and leave it out in the rain, effectively it rusts. You're adding oxygen to the mix. And that's likely what the clays are dominated on Mars, so that gives it the red color.
A lot of things that you're finding out, though, for the first time, aren't you?
Oh, yeah, this is a fantastic place we landed. It's a cornucopia of different rocks, and we just can't wait to get them all.
Could you be a little more enthusiastic?
We have another question from one of the school kids.
My name is Catherine Fox. I'm 9 years old and from Atlanta, and I want to know why Mars has so many holes.
Matt, I think that's yours again.
Well, it's been bombarded by meteorites from outer space, and those meteorites hit the surface, and they create holes, in fact, and the material flies out of it, creates actually a rim that's higher than the surface, and generally a bowl-shaped crater for small ones and more serrated ones for larger craters. So that's why it's got so many holes.
And it's got a lot of hills, too, we were talking about. More than
Great
you
hills,
thought.
yeah, especially this particular place.
I think we have another question from another.
Hi, I'm Keith Roseman, and I'm 10 years old, and I'm from Atlanta, Georgia. And I want to know how much time exactly did it take to build the Pathfinder?
Brian Muirhead, that goes to you. I mean, that one was the one that kept you up at night, didn't it?
That's a pretty straightforward one. We started the project in October of 1993. And then we built it, we designed the spacecraft, we built it, we tested it, and we launched it in December of '96. So it was about 38 months to design, build, test, and launch.
Brian Cooper, how long did it take you to get proficient at driving a rover where you felt comfortable?
We've been practicing for quite a while, both in the sand pit area we have up in our facility, test facility, but also before then, when we first developed the rover. But very intently for the last year. So probably about the last year we've been doing our all-up system tests, and it's taken a while to get a feel for the system and calibrating it. But it's nothing like looking out on the surface. It's night and day. It's just so great.
It's different than you thought it would be?
It is. We've never been able to test looking at far distant mountains, and that just breathtaking looking at it in stereo. Now, we're not probably going to go out to the far distant mountains, but the system, it works really well, and we're real happy with it.
Let's take another question from one of the kids.
My name's Joel Withrow. I'm from Atlanta, and I'm 13. I was just wondering, what's the average temperature on Mars?
Temperature on Mars. What's the temperature like on Mars?
It's cold. I'll just say what the weathermen on Mars say, which is that it's maybe 5 to 10 degrees above zero to about 100 degrees below zero. Pretty cold place.
That's not...
And this is summer.
And this is summer. That's pretty much what you expected. There was no surprise there.
Yeah, it's about 100-degree C change, and so yeah, the temperature swings are enormous.
Enormous. We have yet another question.
Hello, I'm David Moyer, and I'm 12 years old from Olenton, Maryland, and my question is, how long will this craft stay on Mars?
Forever. This is a monument to man's ingenuity to place a spacecraft on the surface of Mars. And women.
Very good.
And humankind. Excuse me.
I get that question a lot from school children, and they ask, when is it coming back? And I say, well, maybe someday, if you study hard and you'll become an astronaut, maybe, and in the future, you get to go and bring Sojourner back. Who knows?
Well, how long, one of the questions we always hear, though, is how long will it continue to work, to function?
Well, there's right now, the way the spacecraft is performed now, it looks like it could go on forever. But realistically, eventually, as things get colder, eventually the lander and the rover will stop functioning. But it could be weeks, it could be months. But as long as it's running, we'll keep operating.
But anything we get from this point is gravy, because we have fulfilled all the mission objectives already. And so everything now is just added attraction.
But we have not fulfilled this project scientist dreams yet.
Well, but those are never to be fulfilled.
No, we need a year on the surface with this little beastie.
I was going to say all of the objectives completed within a week,
right.
Except for, of course,
Matthew. Yeah, well, but you can't satisfy him.
Can't.
By the way, we should tell people that in 2005, we're going to try to launch a mission that's going to bring a piece of Mars back to Earth in 2008. So the first thing that comes back will be the 2005 launched mission.
This has been wonderful. I have to tell you, part of this mission is about introducing kids to a whole new world. But not just the world of Mars, the wonders of science. And scientific achievement can begin at a very early age, and who better to tell us about that than Donna Shirley now and Donna Shirley then. No. Who knew this Oklahoma schoolgirl would one day grow up to be the program manager of a mission to Mars? Well, maybe one of her teachers had a glimmer.
Oh, dear.
Well, I told several of them the sky's the limit if that's where you want to go, you know.
And she did.
She did, that's right, she did. She really did. Yes, we've had great athletes and great students in all fields, but none could top this one, I don't believe. She's great.
Well, what more do we say? This has been wonderful sitting here and chatting with all these folks, John, and they are really have made it a wonderful week for us out here, accessible all the time, and explaining it in English so you and I can understand it and present it to the rest of the folks around the world. John?
No kidding, John. Hey, I know that you guys in Pasadena have the 3D glasses. I've got some. Get them ready. They'll give you a glimpse of what it's like to gaze toward the horizon of a new and different world. That is just ahead. Stay with us. Welcome back. Every day, we have been scrambling for superlatives to describe what the Mars Pathfinder has been showing us. This little spacecraft just keeps topping itself. Well, today's no different. Scientists have assembled Pathfinder images into a three-dimensional panorama. So put on your special 3D glasses. I had no idea this would work, but it does. Take a look at this. We'll watch together. Now, you see the rover, Sojourner, right there on the left of your screen. And this was before she went over to the rock Yogi Bear, which you see just moving off the left side of your screen right now. At the bottom of your screen, you can see one of the Pathfinder solar panels sticking out, along with the airbags. And if you have these 3D glasses, I mean, you can really see that the airbags are rising up off the surface of Mars. And as you look out onto the horizon, in a minute, you'll be able to see some of these mountains in the distance, and some of the Twin Peaks may come across. There's one of the mountains in the distance just coming on the upper right-hand corner of your screen. These are the things that the Pathfinder mission didn't know it was going to find. Now, coming into view in about the center of your screen now, out about halfway back, you can see what they call an arroyo. It's sort of like a stream bed where the land has gone down because of the water washing across it. And at the bottom of your screen, you can see the ramp that the rover was able to get off of to begin its journey around the surface of Mars. There are the Twin Peaks now, just beginning to come across your screen from right to left. And as I say, I had no idea this was going to work on television. We knew that if you got in the room with this picture, you could see it. But the fact is, if you have these 3D glasses with the red and blue thing on them, you can really see this. All right, I think we're back to the rover now. Back to Yogi Bear, and as I say, those 3D images almost make the photographs that have been wowing us for a week look commonplace. Pathfinder is dominating the newsstands and the airwaves with newspaper spreads, magazine covers, and programs like this. CNN's Jill Brooks shows us the Martian media invasion.
Some say that journalists are always looking for dirt. Well, now they've found plenty of it on Mars. The story of the Pathfinder landing on Mars has turned into pay dirt for the media. The Sci-Fi Channel's ratings have soared,
Science has now taken center stage.
as well as CNN's and others. Magazines and newspapers have Mars mania. And NASA's Mars website had more hits than Madonna. A record 1 million people have logged on.
Mars has been a bonanza for the media because of this fascination with what could be there and the fact that we're actually there. And for a while we were kind of looking inward to ourselves and nostalgia, but this is a time with the millennium coming where we're very interested in what the future will be.
Because of what you have done, the heavens have become a part of man's world.
Not since Neil Armstrong stepped onto the lunar landscape has the world been so over the moon about space. The Mars mission provided no pictures of astronauts walking and talking in space, but in some ways it is more of a giant media leap. There are far more news outlets to provide coverage. Plus, interest in the Mars mission is heightened because of its symbolism in pop culture.
We use the word Mars so much. That's Martians. You know, that's what we've always used in our sort of the mythology we've created about outer space. We are sci-fi junkies in this culture, and this is the real thing. And everybody is hoping that some little person is going to run out and wave at the camera. I mean, everybody wants to believe that there's life on other planets.
Mars is more than 140 million miles from the sun.
Mars was put on the cultural map with War of the Worlds. And since then, entertainment vehicles ranging from Total Recall to My Favorite Martian to Mars Attacks have used this planet to project our fantasies and fears about alien life. Meanwhile, news stories can impact the entertainment industry also. Some video stores report a surge in sales for space-related films. Thanks to film, here's what we were expecting from Mars. And here's what we got. But no one seems disappointed, especially the media. Jill Brooks, CNN, New York.
The scientists on the Mars mission really have rocks in their heads, or make that on their minds. When we come back, the fine art of naming rocks. Stay with us. The major features of a planet like Mars have to go through a formal and time-consuming naming process. But this little section of the Mars Valley has been populated with catchy names, many of which we all grew up with. Here's CNN's Jeannie Mose to look at some rock stars destined for the Interplanetary Hall of Fame.
What does this rock have to do with this bear?
I'm smarter than the average bear.
Apparently, you have to be a rocket scientist to see the resemblance.
And we move toward Yogi.
Forget famous earthling rocks like Plymouth Rock or the Rock of Gibraltar. Barnacle Bill is #1 on the rock charts these days, though maybe not for long.
We will also look at Scooby-Doo in some detail. And Casper. Don't forget Casper.
Who could forget Casper? Not the whitish rock, the ghost.
What are you made of?
Funny, that's what they keep asking the rocks. Rocks with names ranging from souffle to shark, from platypus to hedgehog. At the Jet Propulsion Lab, there's a panoramic view of the landing site on the wall, dotted with the names of the rocks.
And what these guys do, they take the little yellow stickies, and somebody comes along and says, my turn to name a rock.
At least you can't call these scientists stiffs.
I mean, they could call these rocks, you know, ALH 84001 or something, but that's boring.
You know, it's Barnacle Bill. Everybody knows what that is.
Well, not everyone.
Oh, dear, what was the little one? Yogi's the big rock.
There was some confusion among non-scientists attending a Mars event at the American Museum of Natural History.
Yogi was named after my favorite horse.
Horse? Hey, don't feel bad, kid. Even the scientists get confused.
I'm not sure if it's shark or wedge, but there's one in the fork. Wedge, I'm sorry.
What's the other one named?
Scooby-Doo?
Scooby-Doo, right.
Now, nobody claims there's a resemblance between the rock and the true Scooby-Doo. The scientists were just being humorous with this one, but many of the names have to do with the rock's appearance. Hippo is shaped like a block. Flat Top and Little Flat Top are flat. The big rock named Yogi likewise has a smaller companion named Boo Boo.
Wait here, Friar Boo Boo.
The team's most junior member has been anointed naming czar. Nathan Bridges keeps track of the monikers. Personal names are a no-no.
Well, we had a rock named Bob, and that'd be great to all the Bobs in the world, but then if we have Bob, we might want Fred or Sally or something.
Some back on Earth think the names should be heroes young folks could look up to rather than names picked on a scientist's whim.
Or we're going to start hearing Martini or Cigar.
The public may be able to toss around names of Martian rocks, but do folks know the name of the American astronaut aboard the decrepit space station Mir?
I have no idea what his name is.
Heard it a couple of times.
Michael something, isn't it Michael something?
Michael Foale. Maybe it's a good thing science is starting to sound like a romance novel.
Rover has nestled up and kissed affectionately Barnacle Bill.
She has now tasted Barnacle Bill.
Any hotter, and they're going to have to order a cold shower for Rover. Jeannie Moe, CNN, New York.
Too good. Naming rocks may be an out-of-this-world experience, but a lot of us are wondering when the time will come for Earth visitors to actually go here and pick up those and other Martian artifacts. Let's go back to the Jet Propulsion Lab and CNN's John Zarella with a look into the future.
John, and the future certainly is very bright, and we're joined again by Donna Shirley, head of Mars exploration here. And Donna, that's the question on everybody's mind. So when do humans finally go?
Well, humans go when we've, number one, scouted the terrain for them. We're like the Lewis and Clark expedition, going with our robots out to scout the terrain. They'll go when we've had enough time on space station to understand whether humans can really live in space for 3 years, which is the round trip. And they'll go when the technology's developed enough so that we can be able to afford to do it cheaply.
That's the big issue. Now, do you believe that any kind of mounting of a human mission would have to be an international mission?
Oh, almost certainly. Even Pathfinder's an international mission. It has German parts to the camera, and the spectrometer is part German, and these Danish magnets. So there's already an international flavor to almost all the missions. And certainly International Space Station is going to be a model, I think, for how we mount these large human missions.
Do you think that the success of Pathfinder and the hoped-for success of the subsequent missions will continue to whet the appetite for sending humans? Do you think, has this been a shot in the arm?
Well, it's very difficult to say because human space exploration is more expensive. It's dangerous. You know, you have to spend money making it safer. And there's a big project right now called Space Station that has to get finished before we could embark on a Mars mission. So I think that it can't hurt. But I don't know, you know, the interest of people comes and goes and wanes and so on, so I can't really predict it.
Oh, you can predict, though, that in the next decade or so, 10 years, you will have a measured buildup, as they say.
That's right. In fact, we have plans all the way through 2016, and by 2016 we hope to have 3 pieces of Mars back, which is going to give us a chance at looking for if there was ever past life on Mars. And that's just about the same time frame that we'd like to mount a human mission to Mars. So it all kind of fits nicely together.
The big mission that everybody is looking forward to in the next 7, 8, 10 years would be a sample return mission, correct?
Right. And the plan right now, if we get the budget that we've put in for in the President's budget this year, is to try a sample return in 2005. Now, it's a 3-year round trip because of the way Earth and Mars are going around. So by the time we get it back, it'd be 2008.
I have to ask you the question. We haven't talked about it on the show tonight. Life on Mars. We know we're not going to find it with this mission here.
Right.
Other missions will be more geared towards finding life, knowing where to go. Is there a good possibility we'll be able to answer that question in the next decade or so?
Well, the best scientists in the field, the best Mars scientists, believe that if we can get well-selected samples of Mars back from very carefully surveyed, first you survey from orbit, get the right places, you know, find the Yellowstone Park or the Mammoth Hot Springs and go there and get the samples. That'll give us our very best chance. Now, this is not easy. If you've ever gone out and tried to find a fossil on the Earth, it's not easy. And these fossils are, you know, way below what you can see.
Well, I know that if anyone can do it, it certainly is the team here at the Jet Propulsion Laboratory, led, of course, by Donna Shirley. a tremendous team, John Holloman, and it's been certainly an honor for me to be here amongst them for the last week and a half. John?
Wish we could all stay, John. You know, in a moment, we'll look back on this week of exploration, excitement, even exultation. Stay with us. There are times here at CNN when you know you've touched a nerve. The phones ring off the wall, the email backs up, your personal answering machine is always filled with 40 or so messages, and people ask for your autograph when you go out with your family to a movie. This week has been one of those times. The fact that humans have established a presence on another planet this week may pale in comparison to some of the other stories in the news, but not in the minds or the hearts of the people who watch this network. You have let us know that you like our extensive coverage of this little piece of America's space program. And you are not just Americans, but citizens of hundreds of countries who have gotten in touch with me and CNN to let us know you like a story that's more good news than bad, that takes you to a place you've never been before, and where, unlike most of real life, everything seems to work. Thanks for joining us. For the team of dozens of women and men at CNN who made this week possible for us on TV, it has been as much fun as it seemed. Here's one more look back to the future.
3, main engine start, 1, 0, and liftoff of the Delta rocket with Mars Pathfinder. And the vehicle has cleared the tower.
DDL Commons report that a signal is barely visible. Let's go home. We can't go home yet. There's still a lot of uncertainty.
That airbag is not fully retracted. We don't quite know why that is.
We have rover data. Yeah!
Communication link between the rover and the lander is working. That has been a big concern.
Rover, don't forget to call home occasionally.
On behalf of President Clinton and all of the people of our country, congratulations on doing an absolutely outstanding job.
What a day. What a night. What a time to be alive on planet Earth.
Well, we can assure you it's not a hoax. We are on Mars.
There is no place on Earth where the rocks are this old. On Mars, they are ancient, ancient stuff.
This is the first time that two spacecraft have ever taken a picture of each other.
Our rover has nestled up and kissed affectionately Barnacle Bill.
But remember, the imagination is very important to understanding this mission, and we will try and help stimulate your imaginations as we will stimulate our own.
This is unbelievable. You have 70 scientists like kids in candy shops here at the end of fire hoses of data who just grinning from ear to ear. We're already seeing differences in colors, in textures. There looks like there's layering in some rocks. There's that one flat-topped rock and what are those? We gotta go see them.
So I think the whole planet was behind us. You know, we did the engineering, but I think the people of planet Earth willed Pathfinder to life on the surface of Mars.
The joy that fills my heart has overflowed my body and risen to the heavens and has reached to Mars.
Wissenschaftler der NASA haben den zeitweise unterbrochenen Kontakt zur Marssonde Pathfinder wiederhergestellt. Zudem gelang es ihnen, das Roboterfahrzeug Sojourner wieder zu befreien. Sojourner hatte sich mit einem seiner 6 Räder am Felsen Yogi festgefahren.
Sojourner hat den Crash mit dem Stein Yogi heil überstanden. Im Laufe des Tages soll das Roboterfahrzeug jetzt die richtige Position erreichen, um mit seinem Spektrometer den Felsen zu analysieren. Die NASA hat unterdessen eine neue Animation veröffentlicht, die die Landung der Marssonde Pathfinder zeigt. Den Zuschauern im Kontrollzentrum in Pasadena wurde außerdem ein neues Panoramabild der Marsoberfläche vorgeführt. Mit speziellen Brillen konnten die Betrachter einen dreidimensionalen Eindruck des roten Planeten bekommen.
Nach einer äußerst erfolgreichen ersten Woche hat es kurzzeitig Probleme mit dem Roboterfahrzeug Sojourner gegeben. Das Marsmobil war vor den Felsbrocken Yogi gefahren, den es als nächstes unter die Lupe nehmen soll. Christoph Lang berichtet.
Auch bei der NASA gibt's peinliche Pannen. Als man gestern das Marsmobil von seinem Felsen wieder wegrangieren wollte, da verpasste man den Zeitpunkt, die Steuerungssignale zu schicken. Wir versuchten sie zu überspielen, als der Empfänger schon abgeschaltet war, gestand Missionsmanager Richard Cook ein. Heute wurde der Fehler dann korrigiert, das Marsmobil, jetzt läuft es wieder. Es ist völlig in Ordnung, es hat nur nicht das getan, was wir von ihm wollten. Die NASA konnte trotzdem was Neues präsentieren. Eine faszinierende Computersimulation nämlich. Sie führt zunächst zu Barnacle Bill, dem ersten Stein, und zeichnet dann den Weg des Marsmobils nach hinüber zum zweiten Untersuchungsobjekt, dem Felsen Yogi. Inzwischen glauben die Forscher auch zu wissen, was den Marssand rot färbt. Magnemit, ein auf der Erde seltenes Mineral. Und der Marsboom greift um sich, er hat jetzt sogar die Kinder erreicht. Raumfahrtspielzeug ist derzeit der totale Renner in den USA und die Mini-Marssonde für zu Hause ist fast überall restlos ausverkauft. Wer mehr will als nur ein Spielzeug, ist bei diesem Mann richtig. Dennis Hope hat sich als Besitzer des roten Planeten registrieren lassen, was man ihm irgendwie auch ansieht. Und jetzt bietet er im Internet Marsgrundstücke an. Mit $20 sind auch Sie dabei.
Das war wieder unglaublich. Die Amerikaner kommen auf die verrücktesten Ideen.
Der Start zum Mars, das ist ein halbes Jahr und eine halbe Milliarde Kilometer her. Seit der fast perfekten Landung ist der kleine Rover das Thema Nummer 1. Seit einer Woche fährt er kreuz und quer durch die Gegend, schießt Fotos und analysiert Steine und Sand. Die Ergebnisse sind sensationell. Hier hat es einmal Wasser gegeben, vielleicht sogar Leben. Und warum der Mars rot ist, wissen wir jetzt auch. Der Planet rostet. Vorgestern dann der Schock. Sojourner hat sich festgefahren. Das Ende? Nein, heute kam Entwarnung. Sojourner ist wieder frei. Das Abenteuer Mars geht weiter.
Ehrgeizige Pläne gibt es da in Bochum und in Köln.
Die Deutsche Forschungsanstalt für Luft- und Raumfahrt in Köln-Bahn. Hier im Kontrollzentrum sitzt Physiker Dr. Günther Otto ganz alleine vor den Monitoren. Mit der Mars-Mission hat er eigentlich nichts zu tun. Sein Job ist die Betreuung des Space Shuttles. Seine Kollegen sind alle in den USA und ganz modern per Internet zugeschaltet. Am liebsten würde auch Günther Otto die Mars-Mission mitverfolgen, doch Job ist Job und der heißt im Moment Space Shuttle, grauer Astronautenalltag.
Shuttles werden schon zur Routine, nur nicht so sehr für uns, weil wir nicht bei jeder Shuttle-Mission involviert sind. Wir sind immer nur dabei, wenn eines unserer Geräte mitfliegt.
Im Moment fliegt ein Gerät mit, deshalb sitzt er hier. Doch immer wenn es die Zeit zulässt, schaltet er heimlich um auf den Mars. Denn was da passiert, lässt keinen Physiker kalt.
Und es ist natürlich sehr schön, dass am Anfang die Automaten hinkommen, bevor nachher der Mensch dort erscheinen wird. Aber dass mal Leben existiert haben könnte, das ist ja ganz wichtig. Und wenn man dann Zeichen dafür findet, dass das mal gewesen ist, ist sehr, sehr aufregend auch für uns.
Für die Kölner könnte die Sache demnächst noch aufregender werden, denn Kollegen aus einer anderen Projektgruppe arbeiten schon an einer Mars-Mission. Dieser kleine Rover soll in 6 Jahren auf den Mars, ein europäisches Projekt. Im Moment wird er noch im Sandkasten auf Tauglichkeit geprüft, von Lutz Richter, dem Projektleiter. Dass eine europäische Mars-Mission sinnvoll ist, daran können seiner Meinung nach nur Technikungläubige zweifeln.
Zunächst mal muss man Begeisterung für das Thema haben. Also man muss sich irgendwie schon für Planetenerforschung interessieren, sag ich mal. Um überhaupt einen Sinn dahinter zu sehen.
Auf jeden Fall wird die Sache eine schöne Stange Geld kosten. Die derzeitige allgemeine Marsbegeisterung kommt den Kölnern daher gerade recht, denn zahlen muss letztlich der Steuerzahler.
Man muss natürlich auch Raumfahrtprojekte machen, die in der Öffentlichkeit interessant oder auch populär sind. Man kann nicht irgendwelche Projekte machen, die keine Unterstützung durch die Bevölkerung haben.
Fehlende Unterstützung bei Mars-Missionen derzeit kaum vorstellbar. Der Mars boomt. In der alten Sternwarte Bochum wird derzeit sogar an einem weiteren Mars-Projekt gearbeitet. Verantwortlicher Projektleiter ist hier Thilo Elsner, 26 Jahre alt und Jurastudent. Ein echter Raumfahrtamateur. Kein Wunder, dass die Fachwelt zunächst den Kopf schüttelte. Amateure lässt man nicht an Mars-Projekte, auch wenn sie eine 20 Meter Teleskopantenne besitzen.
Mir wurde vorgehalten, wir in Bochum hätten einen an der Schüssel. An der Schüssel haben wir keinen, sondern wir haben ein deutsches Mars-Projekt vor. Das deutsche Mars-Projekt ist das AMSAT P5A-Projekt.
Und daran beteiligen sich mittlerweile auch echte Wissenschaftler. Verantwortlich ist die Universität in Marburg. Dass die gesamte Technik in Bochum aus den 50ern stammt und in denkbar schlechtem Zustand ist, was soll's. Für die Wissenschaftler ist die große Teleskopantenne wichtig, um Daten von der Sonde zu empfangen, die zum Mars hochgeschickt werden soll.
Worum es mir eigentlich nur geht, ist, dass wir die Bochumer Anlage in dieses Projekt eingebunden haben. Das habe ich, kann man sagen, geschafft soweit. Also die Zusage steht. Und jetzt geht es eigentlich weiter, dass wir hier die Anlage und mit dem Trägerverein auf den neuesten Stand bringen müssen und dass Bochum wieder ein innovatives Ziel für die Weltraumforschung wird.
Ein bisschen Fantasie gehört schon dazu, sich vorzustellen, dass Amateure eine Mars-Mission aus einer verfallenen Sternwarte leiten. Aber wo das Weltraumfieber grassiert, da ist Pioniergeist gefragt. Und den haben die Bochumer reichlich.
Noch eine gute Nachricht vom Mars. Die NASA hat den zeitweise unterbrochenen Kontakt zur Sonde Pathfinder wiederhergestellt und das Marsmobil Sojourner konnte sich doch noch vom Felsen Yogi lösen. Ursache des Marskusses, wie die Wissenschaftler den kleinen Unfall nannten, war ein irdischer Steuerungsfehler.
Noch nicht mal einen Blechschaden holte sich Sojourner bei seinem Zusammenstoß mit Yogi. Nur stand der kleine Rover da mehr als einen Tag, weil es die Fahrer auf der Erde zu eilig hatten. Sie schickten den Befehl fürs Rückwärtsfahren zu früh, ein paar Minuten bevor der Rover für die Kommandos empfangsbereit war. Also gab es keine Bewegung auf dem Mars und auch keine neuen Daten. Ärgerlich, aber man habe sich eben entschieden, so scherzte ein Wissenschaftler, am 7. Tag zu ruhen. Als Entschädigung gab es für die Journalisten das erste dreidimensionale Panoramabild vom Mars. Es ist eine Kombination aus allen bisher verfügbaren Daten, die man aber leider nur mit 3D-Brille so richtig genießen kann. Auch die Mars-Fans am Fernsehschirm fasziniert die NASA am Ruhetag mit Hightech-Bildern. So sieht der Fahrer des Rovers die Landschaft rund um die Landungsstelle, als wäre er tatsächlich auf dem roten Planeten. Sojourner hat sich wieder befreit und an die Arbeit gemacht. Er wird die Oberfläche von Steinen wie Yogi und Scooby-Doo untersuchen. Seine kleine Rast gibt den Wissenschaftlern Gelegenheit, die Informationen der letzten Tage auszuwerten, bevor eine neue Datenflut über sie hereinbricht.
Your hard drive for the past week, you have probably seen some of those wonderful pictures of Earth's neighbor, Mars. And if you didn't see it in space, you could for the first time sure catch it on the internet. And that's what millions of people worldwide were doing this week, logging on to the NASA Pathfinder site to see what all the fuss was about.
It was totally awesome. It's very exciting. It's very clear. You know, this is live.
And if you didn't get a chance to see some of those pictures yourself, here's a sample and how to do it. Let's call up the CNN homepage at CNN.com. We'll go down to a section called Destination Mars. We click on one of the Pathfinder sites. We'll choose one at the Lewis Research Center. This is a NASA site. And we have a selection of pictures here, which you can see. Quite good. One of them is this panoramic view of Mars. And we're going to try to get that down for you right now. Okay, now let's take a tour. We're on top of the Pathfinder. And here is the Martian landscape. You can see the ramp down where the rover hit the Martian soil. We go through a bit of the Martian terrain here. You can see some of the ballast from the Pathfinder still at the base. There's the rover. It's moving about on the Martian surface. And as we pan around a little further, we hit more of those ballast bags from the Pathfinder and again more of the Pathfinder again. So that's a panoramic view of the surface of Mars taken from the top of Pathfinder. And it's just some of the things you can see on the internet.
NASA's trip to the red planet is already landing many in plenty of green. Companies are cashing in on the country's fascination with a tiny robotic vehicle roaming the surface of Mars. Mattel is selling a rover action toy complete with a miniature rover and mothership. A portion of the proceeds goes to NASA to help fund the mission. Also, the maker of Mars Candy Bar says sales are skyrocketing. Now,
Aber sicher sollten die grünen Männchen auf dem roten Planeten alarmiert sein, denn die Erdlinge planen nämlich eine Invasion. Mit geschickter Strategie und geradezu perfektem Mars-Marketing macht die NASA den Amerikanern und dem Rest der Welt den Mars schmackhaft. Männer und Millionen werden für den Mars mobil gemacht und selbst Raumfahrtmuffel packt die Gier nach mehr. Elmar Thewesen berichtet aus Washington und das war's dann für heute. Ich wünsche Ihnen einen schönen Abend, wenn Sie uns zugeschaut haben.
Er ist noch trickreicher, noch schneller und noch beweglicher als Sojourner. Rocky ist der NASA-Kandidat für die nächste Mars-Mission. Er mag zwar teuer sein, aber wer kann dazu schon Nein sagen? Schließlich hat sein Vorgänger Kultstatus erreicht, Sojourner als Spielzeug. Die NASA weiß, wie man die Mars-Fans bei Laune hält. All die trockenen Daten vom roten Planeten verpackt sie in wunderschöne Bilder. Aber Vorsicht, die hier sind nicht ganz echt. Der Computer hat nachgeholfen, damit wir alle fasziniert sind. Und es ist auch nicht das erste Mal. Die NASA bessert gerne nach. Erinnern Sie sich noch an die Sterngeburt? Sie war eigentlich ein Schwarz-Weiß-Bild. Die NASA hat die Farben reingemalt. Und da war doch letztes Jahr dieser Felsbrocken vom Mars, in dem man angeblich Spuren von Leben gefunden hatte. Damals gab der US-Präsident eine Pressekonferenz und sprach von einer der erstaunlichsten Entdeckungen, die die Wissenschaft je gemacht hat. Selten so gelacht. Die NASA bekam vom Kongress viel Geld für die Pathfinder-Mission, bevor Bill Clinton auf diesem Dinner vor ein paar Wochen vor Journalisten zugab, dass alles wohl eher ein PR-Gag war. Stellt euch vor, wir sagen, es gäbe Leben auf dem Mars, das haben wir gemacht und ihr habt es uns tatsächlich abgekauft. Man kann die NASA ja verstehen. Dafür braucht sie das Geld. Für den Mars-Raumanzug, für die monatelangen Dauertests an Freiwilligen im Johnson Space Center wird tatsächlich die Marsreise geprobt. Sie würde hin und zurück mit Kurzaufenthalt 2 Jahre dauern. Ein erstes Frachtraumschiff soll 2011 landen, die erste bemannte Mission in 2014. Die passenden Bilder hat die NASA jetzt schon parat, damit das Eintreiben der nötigen 25 Milliarden Dollar leichter fällt. Gleich neben dem Helden von heute steht im Raumfahrtmuseum deshalb der von übermorgen, damit auch die Steuerzahler sich für die Idee Mann auf Mars begeistern können. Und Sie werden vielleicht einmal Mars-Astronauten sein, fasziniert von den Bildern, die die NASA täglich per Internet verbreitet. Es wird nicht in nächster Zukunft geschehen, bremst einer der Sparkommissare im Kongress. Zuerst müssen wir mal die internationale Raumstation bauen. Danach können wir uns nach der nächsten Grenze umsehen und das wären dann Mond und Mars. Dann eben 2020. Da empfiehlt es sich, jetzt zuzuschlagen. Man nehme $20. Dafür gibt es eine Besitzurkunde über 10 Quadratkilometer Mars, eine marsianische Verfassung und eine Landkarte. Und dann schaffen wir Fakten. Was die NASA kann, können wir schon lange.
Good morning. Yesterday and this morning was an excellent day on Mars. The spacecraft functioned flawlessly, the instruments performed superlatively, and the rover did a great job too. We received an unprecedented 90 megabits of data yesterday and this morning, ending at about 5 a.m. this morning, and the science team and planning team has been on the job since then, right up until now, planning the next SOLS activity. Those activities were great. The penultimate was, of course, getting the alpha proton X-ray spectrometer up against Yogi, our friendly rock. And I'd like to first show you a rover movie done by Justin Mackey of the science team that illustrates the careful and complex maneuver required to get the alpha proton X-ray spectrometer up against Yogi. If we could run that, please. Here is the situation of the rover. Just prior to its motion, it has to make a left turn, go forward, make a right turn, extend the APX, and go forward until the APX sensor head actually touches the rock itself. And it moved about a meter in this activity, and it got the APX sensor head directly against Yogi Rock. At least 2 of the sensors on the end of the deployment device contacted and tripped, indicating that we had firmly seated the APX against the rock. And the analysis of that rock was returned this morning and last night, and we hope to show you the results of that analysis. In addition, we returned all of the so-called gallery pan, which is a full 3-color, red, green, and blue, panorama throughout the entire site. That has not yet been put together, but should be made available shortly. We returned other data as well that involves the atmosphere and the aerosols within the atmosphere, predominantly because the Hubble Space Telescope was observing Mars at the same time as we were over the last couple of days. And there will be further presentations that show you how these synoptic views from the Earth, in fact, can be related to measurements made from the surface of Mars. Now, I cannot say that the previous 3 or 4 days went quite as well as yesterday did. We were bedeviled by a series of resets of the lander computer, and that will be discussed in a little bit more detail in just a minute. But to show you what we're planning for the next day, if I could have the, Jim. This is an image that shows Yogi Rock up here to the left. The alpha proton X-ray spectrometer is touching the rock right here. We will uplink a sequence early tomorrow morning that backs the rover away from the rock and does a series of waypoints in which the operators define 2 positions in the scene here that direct the rover to a location somewhere around here where it will do a wheel abrasion experiment in this region, and there will be images taken of the rover in that location. Following that, the following day, we will go through the Cabbage Patch, which is this area here, and get very close to Scooby-Doo, our next target, which is this whitish, flattish rock shown here down near the lander. And finally, the science and rover team have negotiated a long-term program for the rover that involves heading back over to the rock garden, back over behind the rover pedal, and going towards the rocks, eventually known as Half Dome, Wedge, Shark, and Flat Top. So that's the plan. Tomorrow's downlink will be in 2 roughly hour-long sessions, maybe slightly less. We expect to return about 70 megabits of data tomorrow, and those will likely, again, be in the wee hours of the morning as they were this morning.
There you have it, the Pathfinder's progress and the latest word on Sojourner's activities. In fact, a close encounter with Yogi, the Sojourner rover, having been driven over the Martian surface to contact and begin examining a large rock that has intrigued scientists at the Jet Propulsion Laboratory. After a difficult few days, Sojourner back at work. We'll be back with more American Edition right after this.
Und dann sehen Sie Barnacle Bill, den ersten Geliebten, und Yogi, den zweiten Geliebten. 3 bis 6 Meter ist die Entfernung unseres kleinen Roboters, unseres Freundes, der da oben rumfährt, untersucht, und wenn er auf Steine trifft, dann übermittelt er Daten. Und nun ist es so, er hat nicht nur Barnacle Bill getroffen, diesen Stein in Mainz beim Max-Planck-Institut für Chemie. Da kommen die Informationen in Deutschland an. Worin der Beitrag der Mainzer besteht und warum sie beteiligt sind, das schauen wir uns jetzt an.
Seit der Mars-Mission in aller Munde, das Max-Planck-Institut für Chemie in Mainz. Im Keller die schwergewichtig irdische Ausführung eines Spektrometers. Eine Probe, hier ein Meteoritenstück, wird eingelegt, die Vakuumkammer verschlossen, Luft abgesaugt und das Ganze nach einigen Korrekturen mit energiereicher Strahlung beschossen. Ergebnis: Spektrallinien auf dem Monitor, die die Zusammensetzung des Gesteins verraten. Doch auf dem Mars braucht man andere Lösungen, denn niemand legt dort Proben ein. In Mainz entwickelt das APX-Spektrometer, ein knapp 700 Gramm leichtes Gerät mit Riesenleistung. Ist Sojourner in Position, genügt eine Berührung. Und mittels Alpha-, Protonen- und Röntgenstrahlen blickt man in die Chemie von Marsgestein. Ohne Probenentnahme verliert der rote Planet so ein weiteres Geheimnis. Täglich laufen in Mainz die aktuellen Messergebnisse ein. Und jeder gibt hierzu, ein wenig stolz zu sein.
Toll.
Denn nur dank des APX-Spektrometers darf sich die Mars-Mission überhaupt wissenschaftlich nennen.
Diese Art Grundlagenforschung wird nicht dazu führen, wirklich Geld zu machen oder nur sehr langfristig, sehr auf Umwegen. Ich meine, auch dieses APX-Spektrometer ist absolute Hightech und zeigt, dass eben durchaus Deutschland konkurrenzfähig ist oder wir konkurrenzfähig sind mit dem Besten der Welt. Aber das kann man nicht so einfach umsetzen in Mark.
Kosten sparen, wo es geht, und viel wissenschaftliche Kreativität. Nur damit, so scheint es, lassen sich noch Ideen ausprobieren und vielleicht auch Ziele erreichen.
Zum Beispiel irgendwo in der Gegend der großen Vulkane zu landen. Olympus Mons, der größte Vulkan unseres Sonnensystems, gegen den ja alle Berge auf der Erde Zwerge sind. Oder in den großen Graben zu landen und dort zu gucken, wie sieht es aus. Da hat man das Profil vor sich, ähnlich wie im Grand Canyon.
Der in Mainz entwickelte Mars-Rover ist ein Beispiel für Hochtechnologie zu niedrigen Preisen. 4-mal leistungsfähiger als Sojourner und mit 2 Kilogramm 6-mal leichter. Doch solange das Geld fehlt, schafft er wohl nie den Weg vom Sandkasten zum Mars.
Aber ein Verwandter von ihm ist heute Abend bei uns. Dieser kleine Rover ist ein Prototyp und er soll im Jahr 2003 zum Mars geschickt werden und untersuchen. Und dann wird er da oben so ungefähr rumfahren, wie er jetzt rumfährt. Und die geröllhaltige Ebene, wo zum Beispiel jetzt gesucht wird, die war einmal das Überschwemmungsgebiet eines gewaltigen Flusses. Das Gebiet wird Ares Vallis genannt. Lutz Richter, den wir heute Abend bei uns zu Gast haben und der neben mir sitzt und auch immer noch gespannt auf sein Gerät guckt, ist zu Recht übrigens, finde ich. Ich habe ja gesagt, wir haben ihn alle sehr lieb gewonnen. Sie sind der Projektleiter bei der Deutschen Forschungsgesellschaft für Luft- und Raumfahrt für dieses Gerät. Herr Richter, wenn er rauffliegt, der Verwandte des jetzigen Sojourners, was wollen wir da suchen?
Wir werden mehrere Messinstrumente auf diesem Fahrzeug haben, die einerseits die Chemie untersuchen der Steine und der Oberfläche. Andererseits kann man auch mit diesem Arm, den Sie hier sehen, Proben entnehmen und zum Beispiel zur Landesonde zurücktransportieren, beispielsweise um dort nach organischer Chemie im Bodenmaterial zu suchen, was also auch Hinweise auf einfache Lebensformen.
Die erste Frage, die einem Menschen einfällt, der darüber forscht, aber wahrscheinlich auch Laien, ist, welchen Nutzen kann das haben, was Sie dort rausfinden?
Ganz allgemein kann man sagen, es erweitert unsere Kenntnis über den Planeten Mars, wie der Mars sich entwickelt hat bis heute, warum er erdähnlich ist in vielerlei Hinsicht und warum er sich von der Erde unterscheidet im Klima und wie er früher beschaffen war mit flüssigem Wasser und dergleichen.
Wenn das alles klappt, was jetzt auf dem Mars passiert und wenn das alles klappt, was im Jahr 2003 mit unserem kleinen Freund passieren sollte, dann können solche Geräte ungefähr 30 Tage untersuchen und auch senden. Und weil die US-Raumfahrtbehörde NASA eben nicht nur eine großartige technische Agentur ist, sondern weil sie sich eben auch geschickt auf Public Relations versteht, hat sie einen Wettbewerb ausgeschrieben. Dieser Wettbewerb sollte herausfinden, wie das Gerät, was jetzt rumfährt, also sein Bruder, wenn man so will, Sojourner, wie der heißen soll. Gewonnen hat eine junge Amerikanerin.
Im amerikanischen Bridgeport rappt der Alltag unbehelligt weiter. Eine von Arbeitslosigkeit geplagte Kleinstadt im Staate Connecticut. Welten entfernt, so scheint es, der Planet Mars. Was hier erforscht wird, berührt die Menschen in Bridgeport nur wenig. Doch das Marsmobil Sojourner, das bereits seinen ersten außerirdischen Unfall hatte, verdankt seinen Namen einer jungen Dame aus Bridgeport. Valerie Ambroise ist 15 Jahre alt und hat an einem Namen. Im amerikanischen Bridgeport rappt der Alltag unbehelligt weiter. Eine von Arbeitslosigkeit geplagte Kleinstadt im Staate Connecticut.
Welten entfernt, so scheint es, der Planet Mars. Was hier erforscht wird, berührt die Menschen in Bridgeport nur wenig. Doch das Marsmobil Sojourner, das bereits seinen ersten außerirdischen Unfall hatte, verdankt seinen Namen einer jungen Dame aus Bridgeport. Valerie Ambroise ist 15 Jahre alt und hat an einem Namenswettbewerb für die Benennung des Mars-Gefährts teilgenommen. Sie ist Spitzenschülerin auf einem Privatgymnasium, das sie mit Hilfe eines Stipendiums besuchen kann. Zu ihren vielen akademischen und sportlichen Auszeichnungen kommt nun auch noch ihr siegreicher Essay über die Menschenrechtlerin Sojourner Truth. Ich wählte Sojourner, weil sie eine Heldin und ein Vorbild für alle schwarzen Sklaven und Frauen ist. Sie folgte ihren Idealen vom Leben und wie es sein sollte. Ihr Name Sojourner bedeutet Reise. Und sie reiste durchs Land für ihre Ideen und was sie damit erreichen wollte. Der Rover fährt über den Mars und will die Wahrheit über diesen Planeten herausfinden. Sojourner predigte gleiche Rechte und Wahrheit für alle Menschen, insbesondere Frauen. Ich dachte, das sei eine gute Kombination. Sojourner Truth wurde für Valerie zum Vorbild. Wahrheitsfindung ist auch ihr Thema. Wenn sie fertig ist mit der Schule, will sie Gerichtsmedizinerin werden. Doch bis dahin ist noch Zeit. Im Moment trainiert sie erstmal für den kommenden Leichtathletikwettbewerb und hofft, dass sie den nächsten Run zum Mars live miterleben kann.
Das, was wir hier jetzt haben, meine Damen und Herren, ist eine sehr spezielle Kamera. Eigentlich ist es überhaupt keine Kamera, aber ist das Herzstück der Kamera, die uns die Bilder liefert. Sie ist nicht im Laden zu kaufen, dieses Herzstück schon gar nicht. Sie kommt nicht aus Japan und sie kommt auch nicht aus Korea. Sie kommt aus Deutschland. Diese beiden Wissenschaftler, die hier sitzen, sind Herr Dr. Wuttke und Herr Dr. Rainer Kramm vom Max-Planck-Institut in der Nähe von Göttingen. Den kleinen Ort schenken wir uns. Oder wie heißt er?
Katlenburg-Lindau.
Das sind die beiden Wissenschaftler, die das entwickelt haben. Mit anderen Kollegen zusammen, nehme ich.
Ja, die Kamera selber ist ja in Arizona, in Tucson gefertigt worden. Und die Gruppe in Arizona hat also einen Partner gesucht für den Sensor, den optischen Sensor, das Auge dieser Kamera.
Die wichtigste Frage, Herr Dr. Kramm, wissen Sie, was das ist? Wie arbeitet das Ding?
Das ist ein Siliziumchip, der Licht umwandelt in elektrische Signale. Und diese Signale werden an die Elektronik weitergeleitet. Die Daten werden reduziert und dann zur Erde übertragen.
Ich habe von der Kamera gesprochen, aber hier gibt es etwas Besonderes an dieser Kamera. Was ist das Besondere?
Das Besondere ist der riesige Dynamikbereich dieser Kamera, wie man ja auch in den Bildern gesehen hat. Man sieht die kleinsten Nuancen und sehr helle und auch dunkle Passagen ohne Einschränkung. Und der weite Temperaturbereich. Wir müssen uns ja beim Mars auf sehr niedrige Temperaturen einrichten.
Ich wollte Sie mal fragen, diese Kamera, habe ich gelesen, hat 2 Augen, Herr Dr. Wuttke. Jetzt stelle ich mir vor, was sieht die mit 2 Augen? Wie funktioniert das?
Ja, die Kamera sieht im Prinzip genauso wie Sie auch, mit 2 Augen. Wir schauen mit 2 Augen auf den gleichen Gegenstand mit unter 2 verschiedenen Winkeln.
Stereo?
Stereo, genau. Und unser Gehirn bastelt daraus den räumlichen Eindruck zusammen. Und das machen wir dann auf der Erde mit den beiden getrennten Bildern im Computer.
Und das haben Sie entwickelt?
Das hat die Gruppe im Max-Planck-Institut für Aeronomie unter der Leitung von Dr. Keller und verschiedenen Mitarbeitern entwickelt.
Ich wollte mal fragen, das Spannende an der Geschichte ist, wie die Daten zur Erde runterkommen.
Ja.
Jetzt stelle ich mir vor, da fährt unser kleiner Freund rum. Der hat die Kamera. So, und was passiert jetzt? Der guckt. Ist das nicht so?
Es wird ein Bild kommandiert. Das Bild wird aufgenommen durch die Elektronik und an den Bordrechner weitergegeben. Dort werden die Daten reduziert. Das ist ein Beitrag der Universität in Braunschweig und werden dann zur Erde übertragen. Und mit dieser Datenreduktion ist es möglich, sehr, sehr viele Daten in kurzer Zeit zu übertragen.
Sie haben mir erzählt, als ich Sie vorhin gefragt habe, bevor die Sendung losging, was sieht die Kamera, haben Sie mir gesagt, laienhaft formuliert, Atmosphäre.
Ja, wir finden natürlich auch die Bilder schön, die jetzt alle gesehen haben mit unserer Kamera. Aber für uns ist die Kamera etwas mehr. Sie ist ein physikalisches Messgerät. Wir wollen Lichtintensität messen und wir wollen damit die Atmosphäre von Mars untersuchen. Uns interessiert dabei besonders auch der Staub in der Marsatmosphäre und das Phänomen oder den Effekt, den wir dabei benutzen, der ist eigentlich jedem geläufig. Dass wir unsere eigene Atmosphäre, also den blauen Himmel, sehen können, liegt eigentlich nur daran, dass Teilchen in der Atmosphäre das Sonnenlicht zu uns hinstreuen. Und wir haben einen kleinen Versuch vorbereitet, um das zu demonstrieren.
Großartig. Den kleinen Versuch können wir uns vielleicht jetzt mal ansehen.
Sagen Sie mal. Ja, wir strahlen hier von der Seite mit einem Lichtstrahl in eine relativ klare Flüssigkeit. Ein paar Teilchen sind noch drin. Wir sehen von der Seite aus den Lichtstrahl nicht so sehr deutlich. Wenn wir jetzt mal die Teilchen in das Gefäß einfügen können, das Kolophonium.
Vielleicht ist jemand da, der das macht. Wird da was eingefüllt? Da wird was eingefüllt.
Wir füllen jetzt also kleine Teilchen in diese Flüssigkeit ein. Und wir sehen jetzt, dass die Intensität des Lichtes, die zur Seite rausgestreut wird, wesentlich zunimmt. Und wenn wir jetzt mal direkt, wenn das Wasser sich etwas beruhigt hat, wenn wir direkt von vorne gucken.
Ja, was müsste passieren?
Man würde jetzt genau die Situation haben, die wir jeden Abend beim Sonnenuntergang haben. Also das Licht ist ein bisschen ins Rötliche verschoben gegenüber dem normalen weißen Licht.
Ja.
Und wir können mit unserer Kamera über den Himmel von Mars die Intensität des Lichtes messen. Und aus diesen Messwerten Rückschlüsse ziehen auf die Zusammensetzung der Atmosphäre, auf die Art der Teilchen, die dort vorhanden ist, auf ihre Größe.
Faszinierend. Also da muss ich sagen, das hat mich wirklich sehr fasziniert. Ich hoffe, unsere Zuschauer auch. Wissenschaft geht ja immer weiter, sowas wird immer weiterentwickelt. Ich weiß um die Konkurrenzverhältnisse unter Wissenschaftlern. Und das ist ein kompliziertes Thema. Sie grinsen zu Recht, ich ja auch, wie Sie merken. Und es gibt ja noch andere Organisationen, nicht nur das Max-Planck-Institut, sondern auch die Deutsche Forschungsgesellschaft für Luft- und Raumfahrt. Teile davon gibt es in Adlershof. Das ist in der Nähe des früheren Deutschen Fernsehfunks, ein bisschen weiter außerhalb von Berlin. Und was da vorangetrieben wird, zeigen wir Ihnen. Und was da passiert, zeigen wir Ihnen auch mit den Augen der Mission.
Nein, nein, das ist natürlich nicht der Mars, wie Sie schon längst bemerkt haben. Das ist Berlin, von einem Satelliten aus gesehen. Und hier, im Südosten der Bundeshauptstadt, genauer in Adlershof, ist das Institut für Planetenerkundung der Deutschen Forschungsanstalt für Luft- und Raumfahrt zu Hause. Zurzeit das deutsche Fenster zum Mars, denn hier, im zentralen Terminalraum des Instituts, werden die Fotos der Pathfinder-Sonde wissenschaftlich ausgewertet. Aufgabe der Forscher ist es dabei, dem amerikanischen Marsmobil den richtigen Weg zu weisen und Erkenntnisse über die geologische und chemische Beschaffenheit unseres Nachbarplaneten zu sammeln.
Womit beschäftigen Sie sich gerade?
Ja, wir haben ja da diese Fotos vom Pathfinder jetzt bekommen und Pathfinder ist am Ausgang von einem Tal gelandet und da wird vermutet, dass aus diesem Tal in der Frühzeit Wasser ausgeflossen ist. Und was wir hier versuchen ist, dass wir die Orientierung von diesen Gesteinsbrocken vermessen und daraus kann man dann Rückschlüsse auf diese Fließgeschwindigkeit und die Fließrichtung machen.
Können Sie es anhand der zwei Fotos mal an einem Beispiel konkret machen?
Ja, wir haben hier unterschiedliche Fotos. Einmal diese Panoramaaufnahme, so wie sie original vom Pathfinder geliefert worden ist. Und dann im unteren Teil eine Verarbeitung, die wir hier berechnet haben. Da handelt es sich um ein Orthofoto. Da liegt
Was ist das, ein Orthofoto?
Orthofoto, da liegt ein Geländemodell zugrunde und auf dieses Geländemodell wurde die Schwarz-Weiß-Information überlagert. Das heißt, grob gesagt, hier blickt man von der Seite aus auf die Oberfläche, im Orthofoto blickt man senkrecht auf die Oberfläche. Und durch diese senkrechte Blickrichtung ist es eben möglich, Längsachsen von Gesteinsbrocken zu vermessen und daraus eben dann die Rückschlüsse auf die Fließgeschwindigkeit und Fließrichtung zu machen.
Ja, vielen Dank.
Dass es einmal Wasser gegeben hat auf dem Mars, und zwar in Hülle und Fülle, daran zweifelt hier im Institut für Planetenerkundung schon lange keiner mehr. Jedes neu eintreffende Foto bestätigt die Theorie der Forscher.
Wir sehen Gesteinsformationen, Erosionsformen, die möglicherweise von Wasser hervorgerufen sein könnten.
Können Sie uns das an diesem Bild mal verdeutlichen?
Wir sehen an diesem Gipfel, wenn ich ihn ganz stark vergrößere, hier eine weiße, längliche Rinne.
Ja.
Es könnte sein, dass diese Rinne eine Art Mure oder Lawine ist. Und es würde darauf hindeuten, dass Wasser bei der Bildung dieser Lawine eine Rolle gespielt hat. In völlig trockenem Zustand wäre die vermutlich nicht so abgegangen. Wir haben auf der Erde Analogielandschaften, Landschaften, die sehr ähnlich aussehen. Und wir vermuten, dass sie durch die gleichen Prozesse geformt worden sind. Dass man also einen Schluss von der Erde auf dem Mars durchaus ziehen kann.
Wenn es also auf dem Mars irgendwann einmal so ausgesehen hat wie auf der Erde, dann kann es auch sein, dass die Erde irgendwann einmal so aussieht wie der Mars. Antarktis 1984. In der vegetationslosen Landschaft finden Geologen einen knapp 2 Kilogramm schweren Gesteinsbrocken. Für die Wissenschaftler ist er nur einer von vielen Meteoriten, die sie von ihren jährlichen Expeditionen mitbringen. Mit der Registriernummer ALH 84001 versehen, führt er die nächsten Jahre ein eher beschauliches Laborleben. 1996 dann die erstaunliche Nachricht der amerikanischen Weltraumbehörde. ALH 84001 stamme vom Mars und enthalte Hinweise für früheres Leben. So sieht das Szenario der NASA-Forscher aus. Vor ungefähr 16 Millionen Jahren geht ein wahrer Kometenhagel auf den Mars nieder. Der Einschlag eines größeren Asteroiden sprengt Marsgestein vom Planeten ab. Jahrtausende irren die Brocken ziellos durchs All. Einer von ihnen gerät in den Sog der Erdanziehung und schlägt in der Antarktis auf. 13.000 Jahre später. Die Vermutung, der Brocken stamme vom Mars, macht ihn zum heiß begehrten Forschungsobjekt. Am Mainzer Max-Planck-Institut für Chemie sezieren die Wissenschaftler den Stein scheibchenweise. Unter dem Mikroskop verraten die Dünnschliffproben, dass der Brocken einst heftigen Erschütterungen ausgesetzt war. Sein Inneres ist von zahlreichen Rissen durchzogen. Im kalifornischen Stanford zerlegen Forscher die Gesteinsproben mittels Laserbeschuss in ihre molekularen Bestandteile. Das Ergebnis der Hightech-Analysen lässt aufhorchen. Der Meteorit ALH 84001 enthält organische Substanzen, wie sie auch beim Zerfall lebender Organismen entstehen können. Am texanischen Johnson Space Center rückt ein NASA-Team den Gesteinsstückchen mit einem hochauflösenden Rasterelektronenmikroskop zu Leibe. Mit zunehmender Vergrößerung wächst die Spannung der Forscher. Sie entdecken wurmähnliche Gebilde, die an versteinerte Bakterienstämme erinnern. Doch die winzigen Strukturen erreichen gerade mal 1/1000stel der Größe eines menschlichen Haars. Zu klein, selbst für primitivstes Leben, urteilen die Skeptiker. Ähnliche Fossilien irdischen Ursprungs seien 100-mal größer. Sojourners Objekte der Begierde sind ganz sicher echte Marssteine. Deren Analyse könnte den Beweis liefern, ob ALH 84001 tatsächlich vom Mars stammt oder nicht.
Seit 221 Jahren feiern sie ihre Unabhängigkeit jedes Jahr am 4. Juli. Manchmal wird dieser Tag mit einem ganz besonderen Ereignis garniert. Pathfinders Landung auf dem roten Planeten ein exaktes Timing. Selbst wenn die Sonde früher angekommen wäre, vor dem Unabhängigkeitstag, hätte sie dort nicht landen dürfen. Es war alles vorbereitet, das Ganze geriet zu einem gigantischen Medienspektakel. Keine Fernsehstation fehlte, keine Zeitung, die nicht täglich über das Neueste von Barnacle Bill und dem kleinen Rover berichtet hätte. Schlagzeilen, die die amerikanische Weltraumbehörde bitter nötig hat. Sie hat es immer verstanden, die Amerikaner wieder für sich zu begeistern, wenn das Interesse geringer wurde. 1986 sollte die Lehrerin Christa McAuliffe die Schüler des Landes aus dem Weltraum unterrichten. Die Werbestrategen hatten sich diesen Gag einfallen lassen, was als PR-Coup geplant war, ging gründlich daneben. Nach der Katastrophe wurden die Stimmen der Kritiker an der NASA immer lauter. Vorbei die Zeiten, als man vom Ruhm eines Neil Armstrong leben konnte, die Dollars nur so flossen und immer großartigere Projekte geplant wurden. Eine Zeit, in der fast jeder Amerikaner stolz war auf das, was seine Nation im Weltraum geleistet hatte und man die Helden zurück auf der Erde wie einst Charles Lindbergh feierte. Das sind Amerikas neue Helden und so werden sie von der NASA-Werbung auch verkauft. Gefeiert von den Medien und deren Zuschauern haben sie nicht nur auf dem Mars Wege geebnet. Die Nation jubelt, man kann die Begeisterung des Landes, nein der ganzen Welt förmlich spüren. Die Politiker empfinden dasselbe für das Projekt und wenn ihre Wähler das auch tun, dann läuft doch alles gut. Will sagen, Nachdem die Mittel für die Weltraumabenteuer immer mehr gekürzt wurden, wächst jetzt die Bereitschaft, Geld für neue Missionen locker zu machen. Die Pläne für eine internationale Raumstation existieren bereits und bei der NASA spricht man schon offen über einen bemannten Flug zum Mars. Der soll in 25 Jahren stattfinden und 35 Milliarden Mark kosten. Bis dahin muss noch viel geworben werden und die Werbestrategen fangen bei den Kindern an. Wenn die für die Abenteuer begeistert werden können, dann hat man zukünftige Steuerzahler auf seiner Seite. Und so kann man fast den Eindruck gewinnen, als habe der kleine Roboter da oben auf dem Mars gerade den 51. Stern für die Flagge der Vereinigten Staaten entdeckt.
Jetzt zeigen wir Ihnen ein Bild, hoffe ich. Dieses Bild wurde aufgenommen 48 Stunden vor der Landung. Hier ist es, 48 Stunden vor der Landung vom Pathfinder. Und zwar ist es aufgenommen worden vom Global Surveyor. Die beiden Pfeile unten, die Sie sehen, zeigen Stürme. Und zwar nicht einfache Winde, wie vielleicht über der Nordsee oder dem Bodensee, sondern richtige, kräftige Stürme. 200 Stundenkilometer können die schon mal haben. Der kleine Kreis in der Mitte ist nicht die Mitte vom Mars, sondern das ist der Landepunkt, praktisch der Zielpunkt für Pathfinder. Warum ich Ihnen das sage über Global Surveyor ist vor Pathfinder gestartet und wird nach Pathfinder landen. Das hat folgenden Grund. Wir haben eine Grafik vorbereitet, die müsste jetzt kommen. Schauen Sie mal, in der Mitte, der helle Ball ist die Sonne. Da oben rechts ist die Erde und da oben links ist der Mars. Nun dreht sich die Erde schneller um die Sonne als der Mars. Und sie drehen sich auch beide um sich selber. Wenn Sie das auf die Bundesrepublik übertragen wollen, ist es, wer von Köln nach Hamburg fährt, fliegt über München, so sieht es aus. Und der weiße Strich mit dem Satelliten ist Pathfinder. Und der trifft unten im Bild, in der günstigsten Konstellation, auf den Mars. Und beide Planeten drehen sich um sich selber. Das muss ich Ihnen noch sagen. Und das heißt was für die Konstellation. Schwieriger will ich es Ihnen nicht machen. Global Surveyor ist unterwegs. Er wird nach Pathfinder landen, und zwar im September. Wir zeigen Ihnen jetzt einen Bericht über eine Reise, die gerade stattfindet. Das schauen wir uns an.
6 solids up and burning. We're good symmetrical burn on all 6 solids.
7. November 1996. Noch bevor Pathfinder die Erde verlässt, wird die Raumfähre Global Surveyor ins All geschossen. Beide Missionen haben das gleiche Ziel, den Mars. Die Reise von Global Surveyor dauert jedoch länger als die von Pathfinder. Nach 10 Monaten soll die Raumfähre am 11. September dieses Jahres unseren Nachbarplaneten erreichen. Auf der 750 Millionen Kilometer langen Reise werden verschiedene Brennstufen der Rakete gezündet, um den Kurs der Sonde immer wieder zu korrigieren. Letztlich bleibt ein Raumschiff übrig, das gerade mal so groß ist wie ein Schulbus. Heute ist Global Surveyor nur noch 14 Millionen Kilometer vom Mars entfernt. In 2 Monaten beginnt die kritische Phase, der Eintritt in die Mars-Umlaufbahn. Nach der ersten Umrundung des roten Planeten startet ein ausgefeiltes Bremsmanöver. Die Raumfähre nutzt den Luftwiderstand in der Atmosphäre zum Bremsen und gelangt so in eine immer engere Umlaufbahn. Nach 4 Monaten hat sich Global Surveyor bis auf 400 Kilometer dem Mars genähert. Mitte März nächsten Jahres soll die Sonde mit wissenschaftlichen Messungen beginnen. Dafür ist Global Surveyor mit einer Reihe von Spezialkameras ausgestattet, die auf die Oberfläche des roten Planeten gerichtet sind. Ein Marsjahr lang, das sind fast 2 Erdenjahre, wird die Sonde den roten Planeten umkreisen. Eine Weitwinkelkamera schießt Tag für Tag Bilder von Wetter und Wolken, um so Aufschluss über die Atmosphäre zu bekommen und den Wechsel von Sommer und Winter auf dem Mars zu dokumentieren. Punkt für Punkt tastet ein Laserhöhenmesser den Mars ab. So lassen sich genaue Karten von seiner Oberfläche erstellen. Die Wissenschaftler erhoffen sich Aufschlüsse über die Kräfte, die einst auf unserem Nachbarplaneten Berge und Täler erschufen. Der Aufbau der Gesteine sowie die Verteilung von Staub in der Atmosphäre wird mit Infrarotkameras untersucht, die Temperaturunterschiede in farbige Bilder umwandeln. Wenn Global Surveyor schließlich eine riesige Fülle von Daten zur Erde gefunkt hat, beginnt seine zweite Mission. Als Satellit soll die Raumfähre Signale von künftigen Marsmobilen, den Nachfolgern von Sojourner zur Erde weiterleiten. Aber bis dahin könnte Global Surveyor ja vielleicht auch Sojourner selbst sehen und uns ein Bild davon zur Erde schicken.
Wir sind wieder in der Mir mit Sigmund Jähn, weil ich würde ihn gern fragen, das, was Roboter und vielleicht Computer untersuchen können im Weltraum, ist ja eher ein Hinweis darauf, dass wir Menschen im All und zu den Planeten gar nicht brauchen.
Die Computer und die Roboter sollen machen, was sie machen können, was sie nicht machen können. Und was für den Menschen möglich ist aus Sicherheitsgründen, das sollen die Menschen machen. Die Bundesbahn könnte auch ihre Lokomotiven mit Computern und unbemannt fahren. Macht sie aus bestimmten Gründen nicht. Ich glaube, wir reden über Mars. Irgendwie und irgendwann wird der Mensch mal auf dem Mars landen. Das kann man dann nicht machen, nachdem man 30, 40 Jahre ohne Menschen Raumfahrt betrieben hat und dann plötzlich zum Mars fliegt. Das geht nicht. Da braucht man Erfahrung, da braucht man Leute, da braucht man Wissen technischer Art, auch die Gewissheit, dass die Menschen das von ihrer Biologie, von ihrer Gesundheit her aushalten. Und das muss man langsam
Herr Dr.
angehen.
Jähn, ich sage das extra mit dem Doktor jetzt. Sie sind Ex-Militär, Generalmajor AD. Sie haben in der Sowjetunion studiert, Sie sind Wissenschaftler. Müssen Sie nicht die Sorge haben, als jemand, der so qualifiziert ist und der Einblick in die Raumfahrt hat, ziemlich intensiven, bis gestern noch, physisch, dass wir unsere ganzen Probleme in den Weltall schleppen? Umweltprobleme, Industrieprobleme. Verlagern wir die Probleme von der Erde weg, zum Mars, zum Mond, zum Saturn, wenn Cassini rauffliegt am 6. Oktober?
Ich denke, wenn die Menschen mal aufhören, sich totzuschießen, einander totzuschießen, dann müssen sie irgendwas Sinnvolles machen. Und da ist auch die Weltraumfahrt nicht schlecht. Und außerdem, wenn man, ich arbeite nun für die ESA ein bisschen, wenn viele Leute, wie die Amerikaner mit den Russen, jetzt riesige Kollektive oder Teams oder was auch immer, jahrelang zusammengearbeitet haben, haben sie keine Lust mehr, in den Krieg zu ziehen gegeneinander. Das ist für meine Begriffe auch ein kulturhistorischer Aspekt.
Das finde ich auch. Vielen Dank. Und wenn Sie den Eindruck gehabt haben sollten, dass wir mit einigen Gesprächspartnern kritisch umgegangen sind und mit Abwesenden schon erst recht, dann gucken Sie sich mal unsere ARD-Chronik an, wie wir über das berichtet haben, was wir Ihnen heute Abend erzählt haben. Das schauen wir uns jetzt an.
Eines haben sie in dieser Steinwüste aber noch nicht entdeckt: Marsmännchen. Sie haben die Bilder alle im Fernsehen gesehen. Wir haben sie nicht verändert. Wenn Sie die Monster nicht auf den Bildern gesehen haben, als sie im Fernsehen ausgestrahlt wurden, dann waren keine da.
Es fließt ein Datenstrom, ja, so ungefähr, als hätte man Fluttore geöffnet.
When your sunglasses look like this,
Wenn Ihre Sonnenbrillen aussehen wie diese,
that's living on Martian time.
dann leben Sie in Marszeit. Es ist unglaublich. Hier sitzen 70 Wissenschaftler wie Kinder in einer Schokoladenfabrik. Es regnet nur noch Daten und alle grinsen von Ohr zu Ohr. Wie Sie sehen, funktioniert alles perfekt. Die Sonde, die Kamera und unser Roboterfahrzeug.
In Los Angeles und in der Umgebung ist dieses Modell, was in einer großen Tausenderauflage hergestellt worden ist, nicht mehr zu bekommen und wird inzwischen zu Schwarzmarktpreisen gehandelt. Da sieht man, wie sehr die Amerikaner doch von diesem Mars-Abenteuer angetan sind. Tschüss, ich gebe zurück nach Köln.
Es will ich Ihnen sagen, im 40. Jahr der Raumfahrt, die 1957 mit den Pieptönen des Sputniks begann. Global Surveyor landet nicht, er umkreist den Mars. Umkreisen Sie weiter unser Programm. Einen schönen guten Abend.